Business end of a BC-501 Asphalt Distributor. In the training, I like to go over the pipe, understand what the oil is doing back here. It's easier to operate the machine and know what's happening when it should. All the piping is just like irrigating. If you trace it out, have a path where you want the material to flow, have it dammed up where you don't want it to flow, you can never get yourself in trouble. That's a better system than trying to memorize valves. If you do it by memory, well, then there's going to be a time when you forget a valve, leave one open or leave one closed, and then you've got a problem. Trace it out, understand what the oil is doing, and I'm going to go through all of that now. First thing that we're going to do anytime is to get the material to come out of the tank into the piping system. And the first operation that we'll probably do on the machine would be to heat the material in the tank. Anytime that we're heating material in the tank, we want to circulate the liquid in the tank. That is, we want to move it from the back of the tank to the front of the tank. And we do that in order to keep cool material moving past the heat tube. The heat tube is an immersion tube. It's immersed in the asphalt. It's this 8-inch pipe that goes in from the burner, goes forward, makes a loop in front of the tank, comes back, and exhausts out the tank, out the top. That tube gets very high surface temperatures. When we fire that burner, the surface temperature will be as high as 1500 degrees on the heat tube itself. That causes asphalt to coke, and that means that it cooks all of the light ends out and leaves a shale-like material coating on the heat tube. That coke causes you two problems. In the beginning, the coking slows down the heating process. It's a very good insulator, so the more coke you get, the slower that it can transfer the heat. Later on, when that coke starts to flake off, it comes off in chunks like rocks or gravel, and that gets in your screens and gets in your spray nozzles. This gives you problems from now on. The more that we can do to slow that coking down, the easier it makes it all the way around. Let this airplane go by. That looks like a lot more fun. Okay, in order to minimize the coking, we're going to circulate the material from the back of the tank to the front of the tank. Starting out over here, you come around here, you can see the main tank valve is right on the back of the tank. It's directly connected to the tank so that it heats up with the material in the tank. It's not internal. A lot of asphalt distributors have an internal valve. This is not a true internal valve. True internal valves have problems in that they can be plugged up and you can't get them unplugged. This particular valve is mounted on the surface of the tank, right tight against the tank, so it gets the heat but doesn't have the plugging problems. On this particular machine, that valve is air operated. That is, we have an air control here that operates an air cylinder down here that will open that valve. When I pick that up, it opens the valve. When I put it down, it closes the valve. If a little less expensive machine might have a handle out here, then instead of that nice air valve doing the work, you have to manually do it yourself to open and to close it. Also, we have available cab-controlled valve control where that cylinder would be operated by a solenoid valve up in the box and would be switched from the cab of the truck. We only do that if the truck has front and rear suction valves on the tank so that you could remotely change it. That is, if you were going up a hill spreading, of course you'd have the rear valve open. If you went over the top of the hill going down and you were low in the tank, you might want to open up the front valve. And you could remotely do that if it had the front rear remote controls. A little short tank like this has no need for front suction, so it just has the rear power operated valve. We're coming out of that valve into the main 4-inch line that goes into the intake strainer there. Let's go back around that side. This box is the intake strainer, and that 4-inch line from the tank valve comes into this strainer. This has a screen inside it. It has a cylindrical screen with 1/4-inch holes in it, and those are to catch the nuts and the bolts and the eyeglass cases, cigarette packs and hats. Everything that ends up in an asphalt tank gets caught right here at this screen. The screen's easy to clean. It's a matter of shutting all the valves off that come into the screen, taking these 4 lugs off, and the screen basket pulls out of there. Okay, we're coming into this screen housing. Now we're going to go through this valve into the bottom of the pump. This is what we call a pump isolation valve, and it's just that. It's only to isolate the pump from the product in the event that we're going to gravity out of that tank into an underground storage tank, or we're going to pull out of this tank with another pump. Maybe we've gone back to the tank farm or to a hot plant or whatever, and using a different pump than this that we would hook on here. In that situation, we'd want to close this valve and isolate the pump from the product, just so we don't have to clean out the pump after we've done the unloading process. Since that's seldom done, 99% of the time this valve is going to be open. So I say just leave this valve open all the time and only close it in the situation that you are going to gravity off or pump out of here with a different pump. Just close it then and then open it back up when you're done. It's a multi-turn valve, and then when it's got asphalt in it, it's kind of hard to turn. So since most of the time you're going to use it open, just leave it open.
You don't have to worry about asphalt plugging up your pump, or
only in the situation that we were going to run asphalt out of the tank and not use this pump. All the other times we're going to be using this pump, so we're going to clean that pump out anyway when we get done. So that's what I'm saying. If you in those situations where you're going to use a different pump or gravity off, then you would close this valve down to keep asphalt out of that pump. Okay, in circulating the tank, we're coming into the strainer. We're going to go through that valve, going to go in the bottom of the pump and out the top. And if you look down on the bottom here, there's a plate that says asphalt pump. It says forward in the bottom, out the top. Reverse is in the top and out the bottom. And of course that forward and reverse control is in the cab of the truck, and we'll talk a lot about that when we get up there. For right now, we'll just say we're going to run the pump forward. So since we're going in the bottom of the pump and out the top, that means that we've got to run the pump in the forward direction. Okay, in the bottom, out the top, so we're forward. Once we get on top here, the asphalt's got 3 ways that it could go. It could come out this valve. I want to have that closed so it doesn't get all over us and make a bad mess. Okay, it could go this way to this valve. That goes to the spray bar. In fact, that's labeled spray bar right here. Right now we're just circulating the tank, so we don't want it to go to the spray bar, so we would close this valve. Finally, where we want it to go is up that line. I'll point that out with my pointer here. We're going up this line to the gate valve on the top left of the tank, and that is the tank circulate valve, and it's labeled that if you got up and looked at the label. Okay, that line goes to the very front bottom of the tank, and it's there just to circulate material throughout the tank. That is, we're pulling out of the back, in the bottom, out the top, up that line, and that line returns it to the front of the tank. Okay, that's the only thing that we're going to use that valve for. The only time we ever open that valve is to circulate the tank. All other times that valve is closed, and it's very important that it is closed. If you were to leave that valve partially opened and you were trying to spray a specific amount of material on the road, some of the material could leak through that valve back into the tank. So material that you've metered with the pump in order to put down the particular spread rate, rather than go on the ground, has gone back into the tank. So that would totally foul up all this very important metering that we get into on this. Again, the only thing we use that valve for is to circulate the tank. All other times it's closed. When we're heating and circulating the tank, because we are heating, we're going to run the pump. We just run the pump at full speed on the pump control in the cab at a dead engine idle, just like the engine's running now. That runs the pump at about 200 gallons a minute, and that's plenty of circulation in the tank. It does a very good job as far as dissipating the heat. Okay, the next pumping function that we'll do is to circulate the spray bar. We've heated the material in the tank up. Now it's time to circulate the spray bar and get ready to go to work. First thing we'll do is to open the spray bar valve. Go ahead.
How long does it take for the material to heat up?
Normally, kind of a rule of thumb on a spreader like this is about 1 degree a minute. That is, every hour it'll raise the temperature in the tank about 60 degrees. 2 hours, raise it 120 degrees. The materials we're going to be working with are all different grades of asphalt road materials, and some are used at ambient temperature, some go clear up as 500 degrees Fahrenheit. All different grades that are anywhere in between there, so we get into all different products and all different temperature ranges. Typically we would load the truck with hot material and go to the job, or the material that comes to the job and transports is heated. It's in an insulated tank like this, and it'll still be hot. We load it and we spread it. Sometimes it's been in the truck too long or in the tank trailer too long and it's cooled down. Say we're shooting an emulsified asphalt and it arrives at the job at 100 degrees. Well, we want to spread that material at about 160 or 170 degrees, so we would heat on it for an hour in order to get it up to that temperature, raising it at 100 degrees. Next thing we're going to do is to circulate the spray bar. To do that, we're going to open up the spray bar, open here. Our pump is running in the forward direction. The spray bar valve is open. Get up and close the tank circulate valve. That's got to be closed. Anytime we're not heating, that valve is closed. Or if we hadn't been heating the truck, if we get to the job and the material's to temperature already, all we're going to do is open the tank valve, be sure this pump isolation valve is open the spray bar valve and put the pump in forward and turn it on, put it into the circulate mode. Circulating normally 40 or 50 gallons a minute is a great plenty. And we do that with the control of the pump in the cab. On the computer unit, which this is, the computer does that. That is, when we tell it to circulate in the cab, it'll turn the pump to whatever speed we have pre-selected and told the computer to circulate at. This one is probably set at like 40 gallons a minute circulating speed. Okay, we're coming out of the bottom of the tank, in the bottom and out the top again, so that the pump is running forward. We're going into the spray bar valve. From there it gets into the discharge screen, Y strainer. We've got all kinds of different names. Fine strainer has been called 100 different things at our plant. The purpose of that screen is to catch the smaller particles that are in the asphalt and keep them from plugging up the spray nozzles. That's a big conical screen that's 6 inches in diameter and about 30 inches long. Has a lot of screen area, and it has 1/8-inch size holes in it, so it catches some material that could get through this screen now will get caught in the fine strainer. Again, it's easy to clean. The 4 lugs on the end, of course you close all the valves ahead of it, 4 lugs on it, and the screen basket pulls out. Just a little conversation about screen cleaning. There's no set rule on how often to clean the screens. It totally depends on the supply of the product, where the product is coming from, what trucks is being hauled in, and the cleanliness of this particular truck itself. Some asphalt supply tank farms that you work out of are very clean. You may work out of one plant where you can go all season and never have to clean the screen. Other plants you work out of, you might have to clean the screens twice on every load. It totally depends on the condition of the tank farm, on the condition of the transport tankers that are bringing the material, and finally the condition of this tank. If you heat a lot in this tank, if you heat every load and you don't circulate the way I'm telling you to, within a month's time it'll start to coke up bad, and that coking breaks off. Then from then on, you're going to clean this screen for every load. It's a guaranteed deal. If you're very faithful about circulating and never heating without circulating, and you do get good supply, then you'll have minimal screen cleaning. The time to clean it is after the shift. It's when you're all done for the day and you have flushed the machine out. Then is the time you're all done, you've got everything shut off, and now take the screens apart and clean them, because you've just flushed with diesel. Everything is still warm, it's easy to get apart, and you can clean it out easily. Since this is a brand new machine and next week's going to be your first week out with it, after the second or third day, at the end of that shift, stop and clean it. When you're all done, take them apart and clean them. If there's nothing in the screens, well, that's going to tell you could have waited maybe 2 weeks the next time. If the screens are half full, that means that maybe you're going to have to clean every day. And you just have to learn from experience and know what kind of materials you're getting on when to clean. If you ever have spread rate problems or loading problems, if it's not pumping right, the very first thing to check is the screens. The intake screen is the most critical. If you put a rag in that intake screen, it'll totally stop the intake into the pump. If you're asking it to put down a half a gallon of the square yard, and you're only putting down a tenth of a gallon of the square yard, maybe it just can't get the material. Maybe there's a rag in there, maybe there's a hat in there. Hats really plug these suckers. And it's not uncommon. You load these things at a tank farm over the top. The guy's on the top and he's got the lid open and he's got a hat on if you gave one to him. And if he bends over there to see what he's doing, maybe he lost his hat in there. And most likely he won't tell you about it. He'll put the lid on it and figure that's your problem. Catch it sooner or later. Okay, we're into the discharge screen. We're still circulating, getting ready to circulate the spray bar. Okay, we're back to the circulation of the spray bar. We're into the discharge screen, or the Y strainer, and right now Y strainer is an appropriate name because there are two directions that it can go out of that strainer. It could go down that pipe, down the Y to the left. Right now, if it tries to go to the left, it gets to a butterfly valve. There's a butterfly valve right here that's operated by an air cylinder. Okay, this is the main equalizer valve, and the name of it will make sense here in a little while. If you look closely at it, there's a slot on the end of that shaft, and that indicates the direction of the blade on that butterfly valve. Right now that valve is in the closed position because that slot is crossways or perpendicular to the pipe. Since that's closed, the only direction the material can go out of the Y strainer is down the right-hand Y, and that 3-inch line comes down, comes back here to the feed hose. I'm going to step around the other side. You can stay right where you're at there. Very first thing it gets to right here is a swivel joint, and that swivel joint has to swivel. That is, I can move the hose up and down here, and that's so that when the bar goes up and down or sideways, it doesn't put a tremendous strain on this hose. Very simple swivel joint. If it drips, loosen the set screw on it and snug up the pin nut. Snug it up to where it quits dripping and reset the set screw. Okay, if you have to tighten it so tight that it won't swivel any longer, here, before it quits leaking, it's time for a new O-ring. And in that situation, you'd spin the nut off, take the O-ring out of the face, put a new O-ring in it, and put it back together and readjust it. It's got to be free to swivel. If it can't swivel, then I'm going to get to sell your boss a lot of these hoses, and these suckers aren't cheap. You know. 3 of those swivels on the hose. There's the one at the top, one at the bottom, and one on the end of the hose. It's obvious what the top and bottom are. When the bar goes up and down, it lets the hose swivel up and down. The one on the end of the hose is so that when the bar is down and side shifts, it actually tries to twist the hose, and that prevents it from actually damaging the hose when it tries to twist it. It has to be free to swivel right there also. Okay, we're into the bottom of the swing joint. That swing joint has got 2 passages all the way through it. Everything we're dealing here has to be full circulating. We're dealing with asphalt materials that maybe at 300 degrees you can just barely cut them with a knife. At 400 degrees or 450 degrees they circulate freely. Well, obviously if any of that material gets in a passage and cools off, then we're plugged up. So everything on the machine is full circulating. That is, when we're not spraying and we have the material in the spray bar or the piping system, it's moving through it. It's circulating entirely through it back in the tank so that everything stays hot and will immediately spray when we turn it on. The swing joint, in order to be full circulating, all these swivel joints and swing joints have to have 2 passages all the way through them. They have a 2-inch tube inside a 5-inch tube, and that gives us the internal passage and the external passage, the passage between the tubes. Around the outside of the internal tube, inside of the outer tube, is the external passage. Okay, when we come down this hose and get into the base of the swing joint, we get into the external passage. I'm going to stand this wing up and swing it around to the back a little bit here. And then Bob can see it as well as ourselves. Just pop one of your tie wraps off there. We're into the outer passage. That outer passage goes up. Outer passage goes to the rear. You can see that this feed tube is split. It's got a weld seam here. It has 2 passages all the way. The outer passage is hooked us into the forward passage. That forward one goes up to here. Here it gets into the outer passage of this double swing joint here. Outer passage, rear. Now we're into the valve section. Valve section takes us up to the very end. The first place it can cross over is at the end. If we take the cap off of the end of the bar and look in there, the center divider is cut back a couple inches. Okay, we cross over there. Now we're in the forward passage. Forward passage down to the swivel. Here we get into the internal tube. The internal tube goes clear through, so it takes us from the forward part here clear to the rear part here. We're back in the valve section down. Now we're in the rear divider of the feed arm. Internal tube all the way through, internal tube down, and that ties to this elbow that comes out to the very end of the main bar. Now we've got material to the very end of the main bar. The main bar is a single passage all the way through, so we're going to go all the way across. Let me repair my outfit here.
Why does the top wing get asphalt first? Is there a reason, or
This is just all in the circulation path. The path has to be a series path all the way through, and that's just a coincidence that this happens to get asphalt into the valve section before this does. Now when we're actually spraying, We'll get into that in a bit, but when we're actually spraying, it feeds the wing through both of these passages, so that in a sense it's feeding both ends of the wing. And I'll point that out even better when we get to the equalizing part when we are spraying. But that's a good point. On a double fold wing here, it actually supplies this before it supplies this into the valve section. Going to go all the way across the main bar. We're going to do exactly the same thing over here, except in reverse. We're coming across the main bar, through this elbow tube on the end, internal tube up, internal tube clear to the back. Now we're in the valve section. Okay, valve section all the way through to the forward channel up to the very end of the wing. Again, we can cross over here. Now we're in the valve section. Rear section. Now we're in the external passage. Now notice that the very last spray nozzle on the spray bar to get circulation was the inside nozzle on the driver's side outer wing. Now of course this just applies to a double fold spray bar. A single fold spray bar, because it doesn't have this elbow in it here, everything is more straightforward. But on this particular one, and this is the one you're operating, the last nozzle to get circulation is the inside of the outer wing. And that's important later on when we actually do our clean out. We're going to want to check to see that we've got diesel throughout the spray bar. If we have gotten it to this last nozzle that gets circulation, that means we've got it everywhere. Okay, from there we're in the rear channel. Rear channel is outer passage down through the forward channel of the feed arm, outer passage, and of course this outer passage ties back to this feed hose. Okay, we're going back up this feed hose, and this one has the same swivels as the one on the other side. It's identical as far as swivels and seals. Hose up to a T, and that T is right where the butterfly valve was that we started out with. Okay, that butterfly valve, remember we called that the main equalizer valve. It's still in the closed position, so it can't go through that butterfly valve. It has to come out this way through the T and up this line. This line goes to the bypass valve. That bypass valve is an air-operated pressure regulating valve, also an air-operated relief valve. A very simple valve. Just envision a pipe with a cap over the top of this pipe. And we push down on this cap with the air can. That's the brake can up on top. We use it just as an air cylinder. That brake can pushes down on that disc. Okay, the effective area of that brake can is the same as the effective area of the disc in the valve. So if we put 10 pounds of air pressure on that air can, it takes 10 pounds of liquid pressure plus a very slight amount in order to lift that disc. And with that, we can actually regulate pressure on the whole piping system. Now this truck has computerized rate control. Since we use the computer to totally regulate the spread rate, we're not going to use the bypass valve at all to regulate spread rate on this machine. So on this machine, that valve works strictly as a air-operated relief valve, and we're just going to refer to it as the relief valve at the end of the piping system on the spray bar. That valve is tied directly to the master switch for the spray bar. When we turn the spray bar on, that valve is going to close. Whenever the master switch is turned off, that valve is in the open position. That is, the air is cut to it or relieved from it so that the oil is free to go back into the tank. When we turn the master switch on, The air is going to go to that air can. It's going to push down on the disc. In fact, on the computer truck, that always has 50 pounds of air pressure on it. So it pushes down on that disc hard enough that it would take 50 pounds of liquid pressure in the spray bar to lift the disc. 50 pounds is way higher than we ever spread at. The highest pressures that we're going to want you to ever spray at with the machine are around 12 or 15 pounds. 50 pounds of pressure on that is just to ensure that nothing goes back into the tank when we're spreading with it. Get a lot deeper into that when we get into spread rate and how the machine controls the spread rate. Right now we're just circulating, so we came out of the tank, we came through the intake strainer, through the discharge strainer, we went down the right hand side, we circulated out through all of the wing sections, across the main bar, we did the reverse here, we circulated out through the wing and back. Now we're coming back up the feed hose, back to where the equalizer valve is closed, so it has to come up this line, through the relief valve, back into the tank. We're circulating the spray bar. The material is going the entire path. It's going through and around every spray nozzle, the entire path back into the tank. So if we have hot material in it, and we're circulating that at 30 or 40 gallons a minute, everything stays totally hot, so that when we do turn it on, we have instantaneous spray. Okay, this is the most full circulating spray bar in the industry. We have bigger flow passages, everything is freer flowing, and we have totally enclosed nozzle valves. Nobody has totally enclosed nozzle valves except for us and one other small manufacturer in California. The nozzle valve totally enclosed means that the valve itself is inside the circulating spray bar, and it stays totally hot, totally melted. Everybody else has a valve external on the spray bar. Their spray bar is circulating, but the valve has a neck between the bar and the valve. That neck cools off, the valve cools off, and if we sat here today in this cool breeze and circulated for 20 or 30 minutes, well, all those little things would be plugged up, and when you turn the spray bar on, the first thing you get is a worm coming out, and then the worm gets wider and wider, and finally you have a fan. Okay, with an enclosed nozzle valve such as this, we can circulate all day long paving grade asphalt, which is the hottest material. We can circulate that all day long in a 30-degree wind, and when we turn this spray bar on, we have instantaneous spray. There is never any drooling, never drip. We have instant spray, and that's all the major advantage of the totally enclosed nozzle valve. Okay, we've circulated the spray bar, we're going back into the tank. Now we're going to assume that we already know how to set up the pump, and we already know how to regulate things as far as spread rate. In the cab we have pre-selected the width of the spray bar that we're going to turn on, and we're ready to go because the spray bar is circulating now, everything is hot, we're ready to spread asphalt. Okay, when we turn the master switch on for the spray bar, the bar valves are going to open that we've pre-selected, and if we've already pre-selected all the full length, when we hit that master switch, 16 feet of spray bar is going to open. Okay, tied to the master switch, remember the relief valve up here. When we turn that master switch on, that relief valve closes, so no longer can the asphalt go back to the tank. Also tied to the master switch is this main equalizer valve we talked about, the air cylinder on that. It's tied directly to the master switch. When we turn the master on, that main equalizer valve snaps open. Also, down on the swing joint is another butterfly valve on an air cylinder, on each swing joint, here and on the other side. They're tied to the same solenoid control valve as the main equalizer valve. These are auxiliary equalizer valves, or swing joint equalizer valves. When we turn that master switch on, all three equalizer valves snap open. Okay, what has happened, the spray bar is opened, the relief valve is closed, the asphalt is always going to take the path of least resistance. It's going to find the easiest place to go. Well, these valves and nozzles have all opened up, so that's the easiest place for it to go. Material is going out of the spray bar. That valve is closed. It can't go back into the tank anymore, so no longer does it try to go up that line. This equalizer valve is opened. Now we can actually supply the spray bar through both hoses, because this feed hose, because the equalizer valve is open, is now tied directly to the discharge strainer. The oil now is going down both hoses to the spray bar. It actually changed directions in that hose. It was going up the hose, up into the tank. When we turn the spray bar on, the valves change position, the bar opens, the oil's going out the bar, that closes, the equalizer valve is open, now it goes down, so now the material is going down this hose. We're feeding the spray bar from both sides. These equalizer valves, the swing joint equalizers, have opened up. Now it can feed the main bar direct from the swing joint without it having to go out through the wings first. We're feeding the main bar direct. Also, because this equalizer valve and the one on the other side are opened, now it can actually feed the wing through both passages, both the internal passage and the external passage. If you trace it out here, we're coming from this feed hose. If we go directly through this equalizer valve, material can actually go back out to the end of the wing here and up through the internal tube in the opposite direction that it was going when we were circulating. Same on the other side, so now we're feeding the wing through both the internal and the external passage. Essentially, we're feeding the spray bar in 4 major places, each end of the main bar and each end of each wing. All of that adds up to equal spray across the spray bar, and that's why we call these valves equalizer valves, equalizing the feed to all parts of the spray bar. You can see that without that system, if those valves didn't open, the very first thing to get asphalt was the end of the wing over there. So it would shoot the heaviest, and it would get lighter and lighter till you got clear across to here, and this would be the lightest. Okay, there's 2 purposes for all this high-powered machinery. The first purpose is to put the asphalt down in the right place, and that's why we have control of the width, control of the side shift, wings up and down, all those sort of things. The other purpose is to put the asphalt down at the right rate. Everything that this machine does has a requirement of putting the material down at the right rate or the right thickness on the ground. We talk about application rate for asphalt distributors in a unit that's called gallons per square yard. And it's really always a part of a gallon per square yard. Common spread rates are anywhere from 5/100ths of a gallon to the square yard up through 5/10ths. Sometimes you might go as high as 6/10ths and 7/10ths. It's very rare to go over a gallon per square yard. That'll come up now and then, but it's a very rare situation. The majority of the work that this truck will do in its whole lifetime will be in the range from 5/100ths up through 5/10ths in 1/100th gallon increments. That is, you may get to a job and the man might say, put down 33/100ths of a gallon to the square yard, 0.33. He might say, put down 0.27. If you're in Idaho or if you're in Utah, it's very common for the county guy to come out and say, put down 1/4. Well, that's 0.25. That's 1/4 of a gallon to the square yard. And it's just exactly what the unit says. That is, if we mark out a 3-foot square piece of ground, that's a square yard. If we spread 1/4 on that evenly over every bit of that, well, that's 0.25. That's 1/4 of a gallon to the square yard, or 1/4 to the square yard. The technical name for this thing is a liquid bituminous distributor. that means that it sprays liquid asphalt. Not only does it spray it, it distributes it. It evenly distributes it over every bit of the road that it covers. If you go to the job and the man says put down a quart, that means that he wants every square yard of this big piece of pavement covered with 1 quart or 1/4 of a gallon per square yard. We go through some elaborate things on this machine in order to have it put down that quart or 1/4 of a gallon per square yard. Obviously, if we wanted to put down a quart or 1/4 of a gallon to the square yard, obviously if we're asking for a specific quantity for every square yard, the spray bar has to put down the same quantity all the way across the width of it. And that's the reason for all this equalizing system, so that we put down exactly the same spread rate all the way across the spray bar. Very common for an asphalt distributor to not put down the same rate all the way across, and maybe they've asked for 1/4 a gallon of the yard, and very possibly the right hand side of the bar is putting down 5/10 of a gallon to the yard, and the left hand side is putting down 1/10 of a gallon to the square yard. Maybe the average is coming out to 1/4 of a gallon, but nowhere is it actually just right. The equalizer system is very important. There's a few places in the country, a few places in the world that actually test the machines for that. That is, when you go on a state chip sealing job in the state of Idaho, on the first morning of the job you're going to be spraying down the road, and on the side of the road there'll be a yellow van parked, and he'll have spread cotton pads, 4-inch wide, 8-inch long pads, side by side all the way across the width of where you're spraying. And you just continue on. You spray right on across those pads. Well, when you started the job, the engineer told you the specific rate that he wanted. He might have said, I want 0.40 gallons per square yard, 4/10 of a gallon to the yard. Okay, when you spray across those pads, then they'll pick those pads up very carefully, individually, and weigh each of those pads on a precision scale. That's what's in the yellow van. They'll precisely weigh each of those pads and compare their weights and calculate the rate that you put on there. And if you put 4.40 gallon per square yard on all of those pads, they're going to be smiling from ear to ear. If you put 0.2 on some of the pads and 0.6 on other pads, they're going to tell you to go home. Or they may give you one more opportunity to make some adjustments on the truck and pass that test. It's called the transverse spread test. On the second test, if you don't pass it, they're going to run you off. And that's a big deal, because very possibly for that particular job, there's 30 end dump trucks all sitting there with rock in them. There's a chip spreading operation, there's rollers, there's sweepers. Everything out there on that chip sealing job depends on the asphalt distributor, and if you get sent home, there's going to be a lot of people mad. Transverse spread is very important. Some states, a lot of states don't test for it at all, and that's one of the mistakes in the industry, and sooner or later we'll get some of that cured. Okay, we're spraying now. The equalizer valves are open, the relief valve is closed. When we come to the end of the shot, when we snap the spray bar off with the master switch, everything reverses. That is, the spray bar valves close, the relief valve opens, now it's free to go back into the tank. The equalizer valves all snap shut, so now it puts the entire circulation path back in a series configuration, so that it has to go the entire path through the bar back into the tank so that everything stays hot. And that's totally automatic. That's not anything that you have to think about as an operator. The only part about that you should think about as an operator, anytime you're out of the truck, if you're out here at the back of the truck, that equalizer valve, the main valve there, should be in the closed position. And it's just a good habit, if you're back here and you're assuming that the spray bar is circulating, say we're on a job where we're spraying paving grade asphalt, you're out of the truck, you're waiting on the rock crew or whatever, you're assuming that it's circulating. The pump is sitting here turning. Well, if you happen to walk by here and see this rod pulled in on the main equalizer valve, if the rod's pulled in, then the valve is in the open position. If you happen to see that in that position, something's wrong. If that equalizer valve is open, the spray bar does not circulate. In fact, it takes a short circuit. If you trace out what happens, you can see what I mean. We're coming out of the bottom of the tank, in the bottom of the pump, out the top. We're going into the spray bar valve. We come down to here, and remember, the material is always going to take the path of least resistance. It's going to go the easiest place. Well, if that valve is open, it's going to see an easy route to duct through that valve, go right up through that bypass valve, right back into the tank. And it has short-circuited the entire spray bar. Now, there's no circulation going on. It's easy to have that happen. Remember, I said that that main equalizer valve is tied directly to the master switch. Let's say the very last thing that we shoot, we're out here on a chip seal, and the last thing we shot just before we parked was a big long taper. Say we're doing an on-ramp to the freeway, and we just shot the tapered part of the asphalt where it comes out onto the concrete. Well, we went across the bar switches on this fancy machine, shut the bar off one section at a time, all the way across the spray bar. The spray bar is all turned off, but the master switch is still turned on. Okay, if we forget the master switch and leave it on, that equalizer valve is opened, as well as that equalizer valve and that equalizer valve, and the relief valve is closed, also discouraging circulation. Nothing is circulating. It is just sitting there cooling off in this nice cool breeze. And if that goes on for 30 or 40 minutes, when we go to use the truck again, when we go to spray, everything's plugged up. And again, here's all these dump trucks sitting out here, and rollers and chip spreaders, and we're running around here trying to figure out how to get this thing thawed out. It's a real embarrassing place to be. So the important thing, anytime you're out of the truck and you assume that it's circulating, just glance at that and see that the rod is out. If that rod's out, it's circulating, everything's fine.
How would you clean this out if that ever did?
Well, if you're lucky, you'll catch it soon enough that by opening one section of the bar at a time, you can get very slow flow going and you can get it moving enough to circulate. If it's frozen up beyond that, then the only choice you have out on the job is to heat up the spray bar. You can, on a truck like this that has diesel heat, your only choice to do is to get a rag and put it on a piece of fence wire and tie a knot in it and soak it in diesel and light it and burn it, and you warm up a piece at a time, and it's a long, slow process. If you happen to have a weed burner, you can do a little bit quicker, but you can see you have to be extremely careful. You can see all the hoses, all of the fittings, all kinds of things that would burn up easily with a weed burner. If you've got one plugged up hard, the very best way to clean it out is with live steam. That is, go back to somewhere that has a good hot steam cleaner, something that'll make good live steam. Any tank farm has live steam that they use to heat the tanks with. If you have live steam available, if you just screw it into the end nozzle in the spray bar and let it leak there a little bit, that is the fitting that you screw together into that nozzle, you let it leak some, turn the steam on. Steam carries a terrific amount of heat. It's one of the best heat transfer media as there is. Well, it'll carry a terrific amount of heat. If it's leaking out there a little bit, that area will heat up fast. Just as soon as it's warm, you open that first section. That section is warm. You're making a mess. You got to do it someplace where it can run out on the ground. As soon as that's warm, the steam is in here and it's circulating, and it'll heat this one, and you open that one up. And within 2 hours or so, you can go all the way across the spray bar like that. The live steam isn't going to hurt anything else. You're not going to burn anything up. As by far the my tongue untied, the very best method to get one unthawed. Okay, we've circulated the spray bar, we've sprayed with the spray bar, we've shut it off. The next operation that we're going to do as far as the piping goes is to load the tank. Let's say we've shot out our first tank load. There's a transport tanker parked alongside the road that we're going to pump off next. As we drive up and back into that tanker, we have been spreading. That is, the whole truck is in the circulate mode. It's circulating when we're going down the road. Anytime we're not spraying and we're on the job, it is circulating. As we back up to the tanker, we're going to set the brake. As we get out of the cab of the truck, put the pump into full speed reverse. It was running forward. Anything else, the spraying, the circulating we're going to do, was always in forward. As we get out, put it into full speed reverse. Come to the back of the truck, bring our hose, put the hose on the tanker, hook the hose up to this top valve here. We call this a loading valve. It has a screen just behind this valve to catch the rags or whatever that might come out of this hose that we're using or out of this transport. We've got the pump in reverse. We open the transport valve. Now we open this valve. The pump's in reverse. It's pulling in the top and pushing out the bottom. Now obviously it's going to try to pull material out of the spray bar because that valve is open. We have been circulating. We have been spreading, so that valve is open. Okay, it's going to try to pull it back out of there, but at the end of that valve, if you trace that all the way through the circulation path, is that relief valve. And that relief valve is just like a check valve. We can push through it, but we can't pull back out of it. So it can't pull anything back out of here. No need to close this valve. Okay, we're pulling out of the tanker through this valve, in the top, out the bottom, pushing the material into the bottom of our tank.
It all goes in the very bottom.
We're just pushing it in the bottom and this fills the tank up from the bottom. Okay, a lot of advantages to that. The first advantage to everything we're talking about, the only valve that we fooled with on the back end of this truck to load it is this one right here. The only thing we've changed. Okay, the next advantage is that we are pushing the material in the bottom of the tank. There are a lot of asphalt materials, specifically emulsified asphalt materials. If we push them over the top of something or dump them in the top of a tank, they foam up real bad. And I mean, they really foam up. If we push in the top here, it foams up and the tank will run over when it's half full. This with all this foam coming up out of it. If we push it in the bottom, there's no foam. Also, that's a totally unrestricted 4-inch passage that we're pushing it in here. So we're pulling it out of this transport in the top, out the bottom, pushing it in there, totally restriction-free. It loads easy and it loads fast. In fact, the only thing that is a limitation on how fast we can load it is this 3-inch hose and the 3-inch valve that we're pulling out of the tanker on. In fact, a good rule of thumb on that, 3-inch hose, 3-inch valving on the intake side of any pumping system is good for about 300 gallons a minute. 3-inch, 300 gallons a minute. If we had 4-inch here and 4-inch hoses, and a few people do that just for speed, if we had 4-inch hose, 4-inch piping, and we had good clean 4-inch valves on the transport, then we can pull 400 gallons a minute. The only thing that's causing material to go through this hose is atmospheric pressure, which at this altitude is about 15 psi, and gravity, and that adds another couple of psi. So maybe at the very most we've got 17 pounds per square inch pushing the asphalt through that hose into here. Once it gets into the pump, then we've got a 200 horsepower diesel engine up front that's pushing it. But you don't pull a liquid. The only thing that you create when you pump away from here, you've created a vacuum, and in pressure terms, that vacuum or the suction that you've created there has created about 15 psi or 17 psi of pressure pushing that asphalt through that hose. If you try to run the pump faster than that, if you try to run it faster than 300 gallons a minute, all you'll do is to cause the pump to cavitate. That is, it will create gaps in the stream of oil coming in there, called cavitation, and that actually slows down the pumping process. So as you speed this pump up, the pumping efficiency goes up and up to a point, and that's the point that's as fast as it'll come through this hose, and then it goes right down fast. And an easy way to tell that on a gear pump is if it starts to make noise. That is, as you're pumping and it's pumping along there smooth, as you speed it up, it'll start to rattle, and it'll rattle to beat hell. If it's rattling, it's cavitating, you're running the pump too fast. You know, all you're doing is losing ground. The fastest, most efficient pumping speed that you can get to is to speed it up to the point that it cavitates and then slow it down to where it just quits. And that's the most you can pull through that hose. And of course that varies a lot with different products. I say a rule of thumb is 300 gallons a minute on a 3-inch hose. But if you have highly viscous product, if you're using something, say you've got some paving grade asphalt in this transport that's only 200 degrees, well, that's highly viscous. And maybe the most you'll be able to pull out of it's 50 gallons a minute just because it's cold and that's all it'll run through there. On the other hand, if that same material were 450 degrees, is very unviscous, and in that situation we might be able to pump 350 gallons a minute just fine before it cavitates. So knowing the products, knowing viscosities, knowing temperatures and all those things help. One final thing that's easy is just if it rattles, you're pumping too fast, and slow it down to where it quits rattling. That's the best that it's going to pump. Okay, we've pumped off or filled this up, whichever occurs first. It's time to stop loading, turn off the trailer valve, disconnect the hose, loosen it up a little bit and let some air into it so it doesn't gurgle a bunch out. Disconnect the hose, drain the hose, just hold it up to where it drains down into here. Now close this valve. Put your hose away and get back in the cab of the truck. As we get back in the cab of the truck, we're going to put the pump back into forward. On the computer, we're just going to tell it to circulate. The pump goes back into the forward direction. That valve's still open, this is still open, the tank valve is still open because we were in the load condition. The only valve we fooled with on the back of this truck to load it was this one, the load valve here. Okay, any questions to this point?
How do you know when you're at your right temperature?
Way back to the heating thing. Temperature, there's a gauge up on the side. There's a dial temperature gauge right there behind the left marker light. It reads out in degrees Fahrenheit. The thermostat is you. Never leave the burner unattended. That is, if you're heating material, if you have that burner running, stay with the truck. You might be in the cab and get out and look at things once in a while, but be here. Now, a lot of things that'll burn on this thing. Once you've used it a while, it's coated with asphalt, it's got diesel on it, it's just a lot of things catch on fire. You need to be here. If it catches on fire, at least you'll have a chance to say, I tried to put it out. If you're off someplace else and it burns down, well, then you can't even say you tried to put it out. So you're the thermostat. You're going to be here when you see the temperature get up to the temperature you want it, shut the burner off and go about your business. We'll get into burner operation totally here in just a little bit. Okay, the next pumping function that we'll do, we're spreading, we're out on the job, we've just reloaded, go back out on the job. Let's say we got a little bit of hand work to do. Got to use the dread handgun, and every now and then you got to get this thing out and use it. In fact, there's times when it looks a lot smarter to use this handgun than it is to try to jockey the truck around so that you can do some little dab with the spray bar. Some guys think that's a point of honor to get the loser honor if they use the handgun when they've got all this fancy apparatus. It's not. There's times it looks smarter if you just stop and get out the handgun and do the little job with it. Very simple to use. If you're going to do hand work as you get out of the cab of the truck, pumping forward, set it on about 60 gallons a minute. Okay, when you come back here, the spray bar is circulating because we've been spreading. Everything is just circulating here, 60 gallons a minute. Right here is a ball valve on top of the pump. That, and it's labeled hand spray. Open that ball valve. Okay, this valve on the handgun itself, when it's crossways with the gun, is in the closed condition. If we open it like that, that's open, that handle itself. Okay, the truck is circulating. It's going through the spray bar and it's freely going back into the tank through the relief valve there. Remember, the asphalt always takes the path of least resistance. When we open this up, in between those two there's 50 feet of 3/4 inch hose. If you trace this from the valve across this pipe goes into a swivel that goes into the hose reel here, comes out of the hose reel through 50 feet of hose into the handle here. Okay, path of least resistance. Well, it's a lot easier to go through all the 2-inch piping and 3-inch piping in the spray bar back to the tank than it is to come out this 50 feet of hose. So you're not going to get anything if you just do what we've done so far. You got to stop the flow from going to the spray bar, so close the spray bar valve right here. Now it's fairly obvious that everything is closed. This is still closed. We haven't turned this on to do the handwork yet. This is opened, but since it can't get out here, there's nowhere for the oil to go, and we've closed off the spray bar. Now, the asphalt pump has a relief valve. It has an internal relief valve that's set at about 80 pounds. So any time that we're in the hand spray condition and we have closed this valve, it's just returning, it's going around and around a circle within the asphalt pump itself. No harm done anywhere. Gives you good pressure to the handgun when you do turn it on. When you turn it on, now everything that is pumping is going to come out through this hose. Then, if you're getting too much pressure, that is if it's spraying out too hard, you've got two choices. Either crack this valve slightly to relieve some of that pressure, let some go back to the bar, or slow the pump down a little bit. Go to the cab and slow it down a little. Do your handwork. When you get to the end of your handwork, you want to clean out the hand hose. Two methods to do that. The first method, the most simple method, is to first of all put some diesel in a bucket. In fact, the truck is equipped with a valve on the back of the fuel tank and a bucket. You put the bucket under the valve, put some diesel in it. We've got diesel in this bucket. Bring it back. Okay, we have been spraying and we've done all of our handwork. Okay, it's time to clean it out. We've got diesel in the bucket. Put the pump into reverse. We were running in forward. Put the pump in reverse and speed it up. This full speed reverse is fine. Okay, now it's pulling in the top of the pump and pushing it out the bottom, and the only thing that's open is the valve to the handgun. Put the handgun in the bucket, open the valve. Now it'll suck the diesel back out of the bucket. Back up just a little bit. Open the hand, no, that's fine. I'm just going to back up. Open the handgun first and let it suck the asphalt, most of it out of it. It's pulling in reverse and it's going to pull it out of the gun and the hose. Then put it down into the diesel and pull the diesel out of the bucket. Just as soon as the bucket goes empty, close the handgun. That's going to leave the hose full of diesel. The best condition you can leave that hose in is full of diesel. Any residual asphalt in there that runs to the bottom of all the loops will be dissolved by the diesel. So the next day we can circulate anything through it. That's the best way to clean the handgun, because when we get all done, we haven't made any mess at all. We haven't had to pump anything out through the handgun. Okay, an alternate way to do it is to do the first cycle, that is pump in reverse, open this, suck the asphalt back out of the handgun. Then close this, go to the cab, stop the pump, close the handgun valve, and open this valve. This is diesel. This manifold right here is diesel. And that diesel comes from the fuel pump on the burner. When we push this burner switch to the wash position, now it's pumping diesel, and this manifold has diesel pumped to it. If we open this valve, diesel goes into the handgun. Okay, with the handgun valve open, do some more spraying. This works especially good if you're priming, because you can continue to spray a little bit and just let it run until you get diesel, where you recognize that it's down to diesel. Then stop, turn this off, close this valve. Again, you're going to leave the handgun full of diesel. Leave the hose full of diesel. That's the best condition. You can always circulate the next day. That's a little simpler. You don't have to get the bucket out. If you're in a situation where you can spray a little on the ground, well, then that's the best method. If you can't make any mess at all, then do the bucket method, because you're going to have minimum mess that way.
Now, where does that diesel, after you sucked it through the bucket, through the wand, where does that diesel go?
Well, the way we did it with the 5 gallons, a couple gallons is left in the hose, and the other 3 gallons just went back into the tank, because we're pulling in the bottom of the pump, pulling in the top of the pump, pushing out the bottom, and it's just going into the bottom of the tank. It's mixing right in with our asphalt material. Nearly any asphalt product that we spray with this truck can have diesel put in it with no harm. In fact, many of the products that you use already have diesel or kerosene or stove oil in them as a solvent in order to thin them down, just like a paint thinner. The only asphalt product that has no diesel in it is when you are spraying paving grade asphalt. And if you're in a particular area, primarily a state where they sample the product and test the product, then you want to be very careful about putting diesel into a paving grade asphalt. Not that it hurts it any, it doesn't do a thing as far as harming the asphalt, but what it does do is ruins the test that they use. They have a test where they test the flash point of the asphalt to see that they're getting pure paving grade asphalt. If you put a gallon of diesel in this tank full of paving grade asphalt, it totally ruins that flash point test. It'll knock that flash point, whereas pure paving grade asphalt should flash at 550 degrees. If we put a gallon of diesel into this 2,000 gallons of paving grade asphalt and they do that test on it, it'll flash at maybe 250 degrees, just because of that little bit of diesel in there as a volatile that will burn. And then they say, well, you didn't bring us paving grade asphalt, and so you don't get paid for the load. So if you're in a situation where you know they're going to test and it's paving grade asphalt, then you have to be very careful about how you handle this flushing thing. And that holds true with the whole flushing project on the truck. And really what it gets down to is knowing when to take your sample and where to take it. If I went to the job with this truck and I pulled a trailer along with me, and I knew that this was a state of Oregon job and it's paving grade asphalt, I know they're going to test it. So the very first thing I'm going to do when I get there, I'm going to go get the inspector and I'm going to say, bring your sample cans. And I'm going to take him to my trailer and I'm going to get him samples of the asphalt, both one for the truck and for the trailer, out of that trailer valve. And if he argues with me, I've got to have one out of the truck, I'm just going to tell him the one out of the truck won't pass. Because this is an asphalt distributor, I have to flush all this equipment out with diesel, especially in order to spread paving grade asphalt. I have to flush it out every day with diesel, and that little bit of diesel in here is going to ruin this test. So I won't give you a sample out of the truck, you've got to take your sample out of the trailer. And if he's a reasonable, intelligent fella, he'll do just that and everybody's happy. If he's not reasonable and intelligent and insists on getting out of the truck, your best thing is just to go on home. because he won't pay you for the asphalt anyway. Once he takes a sample out of an asphalt distributor, it's going to have some diesel in it. And if it doesn't pass the test, they won't pay you for it, so there's no use putting it on the ground if they're not going to pay you for it anyway. Okay, we've hand sprayed, we've loaded it. There's several other pumping functions that we do with the piping back here that we'll briefly go over. Again, it's all just a matter of tracing it out, deciding where you want it to go and where you don't want it to go. Let's say that we come home from the job and we've got 1,000 gallons of material left in the tank, and we want to pump it back into our storage tank, and we want to use this pump. Okay, we're coming out of our tank, so we're coming out of the bottom of the tank into the intake strainer, in the bottom, out the top of the pump. Okay, we're going to put a hose on here and hook it to our tank. Okay, this is the only place we want it to go, so we'd be sure the bar valve is closed, and be sure that tank circulated valve is closed, be sure the handgun valve is closed. Open this, pumping forward since we're going in the bottom and out the top, pump our material off into that tank. When we get done, we're going to clean the pump and we're all done, close all the valves. Another situation, maybe we want to move material from a tank over here to a tank over here. In that situation, we could hook on here from that tank. We could go in the top, out the bottom. Since we're going that direction, our pump is going to be in reverse. We're coming out here to this tank. That tank valve would want to be closed, bar valve closed. Everywhere we don't want it to go, we want to close off. We just want this path open through here. Another situation, this tank over here to that tank over there. We could pull in the bottom here, in the bottom, out the top here. We can go either direction through the pump. We can do it in any combination. That's what happens to be the easiest. One thing to keep in mind, this pump has a relief valve. But the only direction the relief valve works in the pump is in the forward direction, that is in the bottom and out the top. So if we're going to pump into a tank that's got questionable valving, questionable hose, piping, maybe it's plugged up, and that's very common in asphalt tanks. Maybe there's a pipe going someplace and somebody's left it plugged up. If we have any question at all about the condition of the piping, we should always pump in the forward direction so that we have the safety of the relief valve in the pump. If it feels a blockage, it'll relieve in the pump and before it pops the hose, before it makes a big terrible mess. If we're going in the reverse direction doing that, pushing through a closed valve or a plug valve over here, this pump doesn't relieve. It'll finally relieve when the hydraulics see about 5,000 psi of hydraulic pressure trying to turn the pump. But that all converts to about 300 pounds of asphalt pressure. All 300 pounds of asphalt pressure will pop about any hose that we're going to try to pump through. And that makes a terrible mess. As well as it's fairly dangerous because asphalt, and maybe we're pumping 500-degree material. It burns. You know, it French fries you if you get into that. Okay, the final pumping project that we'll get into is cleaning out the spray bar. This is the most important thing that I'm going to teach you on the whole truck. Anything else that we go over, everything else that we do, you can forget, you can foul up, you can do it wrong, and none of it's going to be a problem that really causes you much trouble. If you don't clean it out right, it can cause you a lot of trouble because you might show at a job the next day and have the spray bar totally plugged up. And then you've got to get it all thawed out, and that's real embarrassing if you've got this line of 30 dump trucks and chip spreader rollers and guys standing over you saying, this operation cost me $3,000 to $4,000 an hour. You know, and if you're holding it all up because your truck's all plugged up, well, that's a tight place to be. Cleaning it out is all fairly simple. We have a fairly specific routine that we go through, and we'll start right from the beginning. Any questions along the line, slow me down and back me up. Okay, we're done for the day. Doesn't matter if this tank is empty or half full or clear full, it just makes no difference. We're done spraying for the day, so now we've got to clean out the piping system. Very first thing we're going to do as we get out of the cab of the truck, we always want to have a plan when we get out of the cab because it'll just save us a trip back up there. As we set the brake. That's always step number one. Pull the yellow button out. Be sure the master switch is off. That's part of your habit that you want to form as a proficient asphalt distributor operator. Anytime you get out of the cab of the truck, in the same motion that you set the brake with, be sure the master switch is off. Should always be, if you're out of the truck, it should be off. And this is especially important when we go to clean the truck out. Set the brake, master switch off. Now put the pump into the forward direction. On this computer truck, we're going to put it into manual and we're going to put it on to full speed forward. Okay, when we come to the back of the truck, the pump is going to be running at a couple 100 gallons a minute. It's full forward and it's circulating that fast through the spray bar. It'll be straining a little bit because it works it hard to circulate that fast. Material's coming out of the tank, through the bar, back through the relief valve. Close the tank valve. The main tank valve, whether it be the air operated one we have here, the manual one with the lever, or if it were cab controlled, that's the final thing we'd do in the cab is close the tank valve. Okay, the pump is running in the forward direction, in the bottom and out the top. We just closed off the supply, we just closed off the asphalt. And when we do that, we're going to starve the pump. Anytime we starve any kind of a positive displacement pump, it'll rattle. And it'll rattle like mad just for a few seconds. No harm done, doesn't hurt a thing. It'll just rattle for a couple minutes. You probably won't even hear it. Well, you will too on this one because you're going to close the valve while you're standing here. If it were a cab controlled one, you would close it up there and you'd never hear it because it'd be done rattling by the time you got here. Close that, it'll rattle. Open this. Okay, the pump's running in forward. We just closed off the asphalt supply. We open this, now it's going to pull air in here. It's pulling air in the bottom of the pump. Okay, that old gear pump will pump air just about as good as it does asphalt. We've got the pump running at 200 gallons a minute. We're pulling air in here. Open this wide open so that it pumps a lot of air. Okay, that air is going in and it's going through the circulation path that we talked about. We're circulating, so it's going to push that air through the circulation path. Well, that air pushing through there will push 80% of the liquid back into the tank, as long as the master switch is in the off position. If that master switch were turned on, it would short circuit through the equalizer valve, go right through the bypass valve into the tank, and nothing is cleaned out except for the strainers, the pump, and the bypass valve. Okay, so this is a good time to look at that and be sure that rod is extended on the equalizer valve cylinder. Okay, we're pulling air in through the entire circulation path, blowing the liquid back into the tank. It'll blow 80% of it back into it. Okay, while that's going on, okay, it's pulling air here, take this bucket and go up and fill it up. We go up here, fill it up at the fuel tank, the spigot on the back of the tank, bring it back here, bucket's full of diesel, put the bucket over the hoses and hang it on that hook. Okay, we got a full bucket of diesel there. This valve is open, we're pulling air in here, pump is running forward. Now close this valve, and I'm going to say this should have taken us at least 3 or 4 minutes to do this. That is to get this all going, go up, get our bucket of diesel, and come back. If it's been gone for 3 or 4 or 5 minutes, all of the asphalt is blown back into the tank. Okay, now close this valve. Open this ball valve, this yellow handled ball valve on top of the screen. Okay, this is the intake side still. This is where the pump is pulling on. So when we open that, that valve is hooked to this hose that goes down into our bucket of diesel. Okay, now it's pulling diesel out of that bucket. If you forget and open this valve first and leave this open, nothing will happen. It won't pull any diesel out because it's freely getting air here, and it's always going to do the easiest thing. It won't pull diesel until you close this valve down. Actually, I close this valve down part way to where it's pulling the diesel out of there slowly. And there's a reason for that. If it's pulling diesel out slowly and pulling some air in here, because this is just partially closed, then it's kind of spraying and fogging this stuff through the bar. You've kind of got a combination going through there at the best velocity. That doesn't really matter. You can do that if you want to. You don't do it if you don't want to. This is closed to where we're pulling diesel out there. Okay, the diesel's going in, and it's going the circulation path of the spray bar. It's going to go the entire route. Okay, it's going to come back around, and finally, remember, on the circulation path, we're coming up this line to the relief valve. Okay, on the back side of that line, there's another ball valve. Another 3/4 inch ball valve. It's got a yellow handle on it. Any of these ball valves, when the handle is perpendicular or crossways with the pipe itself, that means it's closed. When we line that handle up with the pipe, it's open. Okay, remember the diesel's coming through the bar. It's going to come back up this line. Open this valve. If we trace this valve out, it's hooked to a hose that comes right down through here, back into our bucket. Okay, we're pulling diesel out of the bucket. It's going entirely through the circulation path. Now it's going to go back into the bucket. Okay, it's got one other place it could go very freely right now. Excuse me. The relief valve is open. It's free to go back into there. Okay, we don't really want it to go back in there, and we've made provision for that. On the master switch, the rear master switch on the control panel here has a flush position. Put that down to the flush position. If you listen to it there, I'm going to turn it back off. You can hear it exhausting air. When I put that in the flush position, it closes that relief valve. Okay, that valve is closed. We just opened up the ball valve there, so the diesel is going to come out the ball valve back into the bucket. Okay, so we're circulating that bucket, and it's going to go round and around. It's coming out of the bucket to do the entire circulation path back into the bucket. Hot diesel cuts asphalt a lot better than cold diesel does. In fact, cold diesel will just bore a hole through the asphalt until it gets heated up, and then it'll start to mix the asphalt. Okay, after it's made a full loop through, when it circulates through this spray bar, it's essentially gone through over 45 feet of 2-inch pipe size passageway with lots of crooks and crannies, and it's heated up by the time it comes back out this. Well, within just a couple minutes, we've got hot diesel here, and it goes around again. The more times it goes, the hotter it gets, and the better it washes out the asphalt. Well, by the time we circulate that bucket for 5 minutes, this thing is clean, and the spray bar is totally flushed. Now, if we're using cut-back asphalts or emulsified asphalts, it doesn't take very much time. One bucket is a great plenty. The bucket will actually be empty most of the time because it empties the bucket out and it'll burp a little diesel back, and it empties out and it burps some back. That's plenty if we're working with cutbacks or with emulsified asphalts. If we're working with paving grade asphalt, then put some more diesel in the bucket, and you can do that just by taking your washdown hose here, put it in the bucket, turn on the fuel pump, and open this valve that goes to the washdown hose, and just let it fill the bucket up. Now that we're circulating the bucket, and if you bring the level up to about half full, then that's a great plenty. You're actually circulating probably 8 gallons of diesel round and around through this spray bar. When you do that, it'll be totally flushed. In fact, by the numbers, if we hadn't blown the asphalt out, that is, if we left the spray bar and the piping system totally full of asphalt, it all holds about 20 gallons. Okay, if we left that in there and we take 5 gallons of diesel and totally mix that in with the 20 gallons of asphalt that's here, and we've got a mixture that's 20% diesel. If you put 20% diesel in any asphalt, any paving grade asphalt, it makes what's called MC250 out of it. MC250 is a cutback, or really it's SC250 because we've got diesel. That's a cutback asphalt that you can pump at ambient temperature. In fact, you can pump it at 30 degrees just fine. So even if we hadn't blown all the asphalt out of this, if it were clear full of asphalt, and we totally mix that bucket of diesel in, we've got a material in that bar that we can pump even in cold weather. And we're fine, as long as we can pump it, that's clean. Now when we talk about clean, we don't talk about color clean, we talk about pumping clean, being able to pump it. We're circulating the bucket, out of the bucket, through the system, back into the bucket. I want to do that for 5 minutes. It doesn't matter how long you do it. It's the ideal time to use the most important piece of gear on the back of the truck. That's his washdown hose. There's 20 or 30 feet of hose here, and that's tied to the fuel pump. On a diesel burner truck such as this, the fuel pump is on the burner. Put the burner in the wash position, and this pumps fuel to wash it. If this truck didn't have a diesel burner, it would have an electric pump up near the fuel tank, and you go up there and turn the electric pump on. Same thing back here. Open this valve and spray it down. The cleaner you keep the back end of this thing, the easier it is to work with, the easier it is to work on. You can see if you got mechanical problems. Everything continues to function well. The diesel acts as a lubricant. Keep it washed down. That's an important part of it. Get all done, coil that up, tie it up so it doesn't get away. We're still circulating the bucket. We've got to do something with that diesel in the bucket. Okay, the easiest thing is to close off the return hose to the bucket first. Close that valve. Put the rear master switch back into the on position, and that relieves the air pressure from the relief valve. Now the material is just being pulled out of the bucket, circulating and going right back in the tank. When the bucket goes empty, drain it out good and take your bucket, put it away. Okay, now close off the valve going to that. We're all done. If you're spreading with the truck every day, I leave the bar valve open because that's what you're using most of the time, and just close it in the times that you don't want it to go into the bar. The tank valve is already closed because we closed it the very first thing in the operation for clean out. Bind the bar up. The spray bar has a binder on each side here. Goes down and latches. Doesn't have to be real tight. That's plenty tight. You can see I didn't strain putting that down. That just takes all the bounce out of it. Put the pins in the wings. Pin in each wing here. That's just for travel down the highway to keep them from falling down in the event something comes apart or a valve gets turned on. When you're traveling with it, fold these wings down. Fold the outer wing down. That takes a lot of the leverage off of the swing joint, and this takes it easier on everything if that wing is folded down. Okay, I'm going to go over a few things on the back end here that are this purely mechanical, things that you should know about. First of all is the binder on the bar that we just used. When we loosen it up like that and it won't come off of there, the bar is dropped down just a little bit. Pick it up with the hydraulics, and now we can get that loose. Always hook them up on the hangers that are here. If you don't do that, when the bar goes down and then comes back up, this runs in some of that expensive mechanism on the top and usually breaks something, and then you've got a leak or a valve that doesn't work. Pins in the wings. On the wings, little box right here, little box here on this double fold wing. This is a tilt switch. It's a mercury switch, just like a electric heater has. If you tilt the heater over, the mercury runs out of the switch and turns the heater off. These are arranged so that when you pick the wing up, it cuts the circuitry to the valves on the wing. That is, this one cuts the circuit to this cylinder, and the marker cylinder, so that they cannot spray when they're in the vertical condition. Even if you turn the switch on in the cab right now for this particular section, it won't open because the wing's up. Same thing here. This one is for the two valves on this section. Those particular switches are arranged so that they complete the circuit until you put the wing almost down. It'll go nearly down. I'll do it on that side so Bob can see it there. When I put that wing down, if it were all turned on, nothing would happen until we got to about that point there, and then it would turn on. Now it'll continue to spray. If I pick it up, it'll spray up to about that height before the mercury switch turns it off. Reason for that, if we want to spray a bank, if we wanted to widen our spray out just a little bit to catch a place we missed out there in the middle, we could do that. When we go on up with it, it would turn off. Okay, on a double fold unit like this, the first day that you take it home, you ought to spend some time, spend an hour or so at the back of the truck, just playing with these functions, the wing lifts and the bar lift. The reason for that, there are some wrecks that you can have back here. If we put that down, and I'm going to put the other side down here, then let's say we have the bar down in the spread position. Okay, let's say that we pick this outer wing up and we have the wing or the bar over here. Now if we pick the inner one up, you can see we're going to have a terrible collision right there. In fact, last night Bruce, our salesman, was demonstrating this truck to some people, and he had a terrible collision on this side. If you look at the hose reel down here, the bend. Well, that's the collision that happens if you do the same thing with the wing on the other side. For those wings to fold up and clear everything, the bar has got to be centered. You center it when you're at the back here, center it just by getting, see the slot down here and the blade, get that lined up to where they'll go together, and that's centered. No problem. Now you can lift that wing and there's no wreck. Okay, you can double switch things, like when they're both up right now and you want to put them both down, you can put both switches down together and they move together. It'll stop when the first one comes to the end. If you let off on it, now it'll go on down. Okay, same thing going up. If we wanted to pick them both up, we can double switch it. We can pick them both up, and for some reason it doesn't want to do that right now. If we're going to go down and we want to pick one up, we can spread them apart. We can do that. Again, when the first one comes to the end, it stops and goes on down. Good idea to stand back here and just play around with these things for an hour and see the wrecks that you can have. From the cab of the truck, the spray bar is centered when the end of the main bar is lined up with the side of the drive tire. Once you've used the truck a little bit, you'll get used to that. Just looking in the mirror, you can tell if the spray bar is centered. Down underneath, and actually you'd have to crawl on the ground to look at it, right down underneath, dead center, back on the spray bar carriage, there's a big bolt. Right dead center is near the hydraulic cylinder that raises and lowers the spray bar. That's the down position control. That is, we want to put the bar down height-wise. We want it to go down to the same height every time without having to get out and measure it. And we can adjust that. That is, there's this mechanical stop there that we can screw in, and if we wanted the bar to come down to that height all the time, all we'd have to do now is get underneath and screw that in and lock the lock nut, screw it into where it touches the cylinder arm and lock the nut. Now every time that we brought it down, it would come down to that height and stop. Now that's set down lower. If we wanted to lower it from where it's at, all we have to do is take the tension off it, get underneath, loosen that bolt up some, get out and see if it's going down far enough, and experiment to where it's at the height that we want. That's the down height control. I'll do this in the down position. The wings have a shear pin right here on the swing joint is a shear pin, and if we run into something with this wing, and sometimes I'm tough enough and sometimes I'm not. There, I did it that time. If we run into something with that wing, it shears that pin and the wing gets out of the way. Okay? And it'll do that either direction. It'll go forward or it'll go reverse. It'll get out of the way. Okay, all we have to do if we do that is put a new pin in it. There's an extra set of pins hanging on the side here. Special fitting we hang them on there is a shower filter loop. Just pull a pin out of it. It's tough enough. And put in a new pin. Just use cotter pins in it. Don't use bolts. Bolts are too hard. They don't shear easy enough, and they wear out the shearing mechanism just because they're too hard. Out in the field, a lot of times you can get by with barbed wire, you can get by with a stick. If you're out of pins, there's some way to get by. Up in the bottom of the valve box, you can see it sticking out right here. There's a yellow handle ball valve right there. That's the main air supply to all of the spreader functions on the back of the truck. Now the only reason for the valve is if you happen to break a hose or break a fitting back here, you can turn off the supply there until you get to the hospital and get the truck fixed. Otherwise, just leave that valve on all the time. On the hydraulic motor that drives the asphalt pump, underneath here is a gear. This is a sensor. That's the speed sensor that senses the speed of the asphalt pump. That reads out in the cab in gallons per minute. And this is the sensor that sends the information, gallons per minute, to the computer or to the GPM gauge, whichever this is equipped with. Underneath the truck, on the rear end, the axle housing of the truck, is another sensor just exactly like that. And that's where we pick up the speed of the truck. We actually count the teeth on the ring gear, and that shows us the speed of the truck. Speed is important, gallons per minute is important. Those are all things that have to do with the spread rate that we're going to put down. We'll talk about that when we get back to the cab. This particular truck is equipped with a service-free asphalt pump. That is, there's no packing on the pump. There's a special seal on it. The seal's good for anything from ambient temperature up through 550 degrees Fahrenheit. You can pump water, you can pump diesel, you can pump paving grade asphalt, and none of those things will affect that seal. If this truck didn't have the low maintenance pump feature, then it would have a packed pump, and there would be a packing here that you would have to adjust periodically in order to keep the pump shaft from dripping. Any questions?
Just back to the time when you're cleaning the bar, when you flush it, should the bar be down or up, or does it matter?
Okay, the question is, when we're flushing it, should the bar be down or up? Doesn't matter. Makes no difference. They can be, everything can be tucked up, it can be folded up, it can be put away. The best and handiest is to have everything unfolded so you can be spraying it off while you're flushing it out. That's the handiest to get at everything and wash it off. If you work at low pressure, and we're going to talk a lot about low pressures when you're spraying, if you work at low pressures, the only thing that'll be dirty on the truck will be the spray bar itself. So if you have it down when you're flushing and washing it off, you're not going to be spraying diesel up around all this stuff that's still clean. If you spray the diesel on areas that are still clean, then it picks up dust and it gets dirty just because of the diesel. If you faithfully work at low pressures all the time, won't be any need to clean this up here, except seldomly, and you just spray it off down here.
Little valves here.
Okay, down on the side, there's a pair of valves. They're called a lockout valve. It's a hydraulic valve that prevents flow from the hydraulic cylinder unless it sees flow initiated by the valve that's controlling that cylinder. And the reason for that, when that wing is in the up position, let's say that we put the wing right there or even clear up, the weight of the wing is trying to push it down. Okay, so it's initiating flow at the hydraulic cylinder. It's trying to push fluid out of the cylinder to let the wing down. Okay, the valve down on the side here is actually a double pilot check valve that won't let that fluid flow unless it is told to by the control valve. So in a nutshell, what that valve does is prevents that wing from drifting down if it's not being controlled by the control valve. If that valve isn't in there, it can actually leak through the control valve and the wing will drift down. If it does that, that is out in the field, the wings drift, or you have a wing that drifts down, it's in the lockout valve, and it's just a matter of taking that lockout valve apart and cleaning it out. Very simple valve. It's got a double ball check in there, and it's probably got a piece of rubber out of a hose in it, preventing the check valve from working. There's four of them, actually, there's 5 on this truck. There's 2, 1 for each of these wings, 2 on this side, 1 for each wing, and then the 5th one is down underneath, and it's on the spray bar itself, the raising and lowering of the spray bar. We want everything to stay exactly where we set it with the hydraulics. That is, if we set the spray bar at that height with the hydraulics, we want it to stay right there. And the lockout valve causes it to do that. I think I've fairly well covered the back end. The rear control panel. Got a master switch on the left-hand side, 3 positions, on, off, and flush. We talked about the flush position for that when we're doing the flush out, we can close the relief valve. All the rest of the time, you're going to leave this rear master in the on position. This rear master is in series with the front master. That is, they both have to be on for anything to turn on. If you put this off and then go to the cab of the truck and try to turn the bar on, it won't turn on. And that'll happen. The very first time that you get in the truck and nothing seems like it works, stop, set the brake, come to the back end and turn that on. Just leave this on. You'll find that now and then somebody comes along and this helps you out. They come along and turn it off just because they think it ought to be off. Okay, the reason for the rear master switch is, well, 2 reasons. In a few places, and the state of Arizona is one, on a state sealing job, a requirement is that you have rear controls on the asphalt distributor. So here it is. You can turn the spray bar on and off. In fact, you could have a guy ride back here and he could turn the bar on and he could turn it off. That's all he can do, but he can turn it on and he can turn it off, and you do have rear controls, so you meet that stipulation. The second reason is, let's say we think we have a plugged nozzle. We look in the mirror and we see a streak back there. We think we got a plugged nozzle, but it's underneath and we can't see where it's at. Well, come to the back, turn the rear master switch off, go back to the front, turn the front one on, now come back to the back, and you can snap the bar on and off. You can snap it on and see what's plugged up. You know, of course, you want to be backed off the roadway when you're doing this, where you can make a little mess, but snap it on, you can see which one's plugged up. If you don't have someone else around to point it out for you, you can find that one, clean it out. Then when you get Then you have to go back to the cab, turn the front master switch off, come back here, turn this one back on, and now you're ready to go back to work again. Other things on the rear control, all of the bar controls, just as they are in the cab, these are duplications. We got the swing, got the lift, and we got the wings that we've been fooling with here. Over here is a pump control. This particular truck is computer control on the pump, CRC, computerized rate control. It has a manual position. In the cab we'll see a manual position on this particular control. In order to use the rear pump control, you have to leave the front pump control in the manual position. You have to leave the speed turn clear down. This is just like the volume on your radio. When you turn it to the left, it's down. When you turn it to the right, it's loud. And you have a forward reverse control. Okay, in order to use the rear, you've got to leave the front in manual, turned clear down, and in the neutral position on forward reverse. Then you can come to the back of the truck. You can turn this to the direction you want, that is forward or reverse, and you can control the speed with the volume knob here. Okay, when you're done, and you do that sometimes for clean out, sometimes for odd pumping jobs, you can control the pump back here. When you're done controlling it back here, leave this, turn clear down, and in the neutral position. If you don't, well, then you don't have manual control at the front. If you leave this turn clear up, when you turn it into manual at the front and turn the forward on, it'll take off full speed forward even if you have the front volume control turn clear down. So always leave them turn clear down and in the neutral position. The last thing on the control panel is the burner switch. 3 position, got on, off, and the wash position. We've already used the wash position. Okay, let's say we're going to run the burner. First step in burner operation, and I normally forget this, now the very first step is to open the exhaust pipe on the burner. Got to climb up on the truck, and there's a little lid, just flip forward on the exhaust pipe. To run the burner, all there is to it is just turn it on. There you go, now we're heating. It's automatic ignition, automatic everything. When we turn it off, it just turns off. That's the total burner operation. Now there's times that very possibly it'll flood. It's just like your car. If it doesn't have just the right mixture when you first turn it on, you may flood it. You may give it too much fuel. And let's say we had turned it on a few times and it didn't light. Okay, to unflood it, put it in the wash position and just let it run for a while. Now that's running the blower, just like cranking your car. You hold the throttle wide open so it can get all the air it can and no fuel. That's the same thing here. This is running the blower, but it's not putting any fuel in. Okay, when it's purged out, if you just switch it on up, then it'll light. Away you go. The motor started and away you go. Again, when you're heating, circulate the tank. Okay, always attend the burner when you're heating and know what it's doing. Do not fire the burner when you're driving down the highway. Number 1, it's against the law in a lot of places. Number 2, the chimney doesn't work right if you're going down the road, and it causes the burner to soot up fast. If you drive around for 2 hours with this burner running, your total heat tube will be sooted up to the point that it won't burn the next time. Then you'll be screaming at us because the burner doesn't work. And if you do it twice, then we put a switch on the truck that won't even let the burner run when you've got the brakes released. So anything else on the back that you see that's a question? All done, just fold it up and latch it all up, and I'll do just that. That's the bar's got to be in the up position, centered. which it's got to move over a little bit, and it'll jump up in if it's not centered when you move it over. Wings up. Wings up and wings down. Pins in the wings. And latch the bar. That's all there is to it. It's ready to travel. That's all it takes to head down the road. Bill, there's a few things around the outside of the truck that I want to point out, just mechanical items. Down here on the truck fuel tank is a fuel tap. We tap diesel right out of the truck tank. The valve here is for filling your bucket. The line that goes out and goes to the back of the truck, that's the fuel to the diesel burner. We mount that fuel tap 8 inches off of the floor of the tank, so there's no way that you can use up all of the truck fuel when you're heating. If you have occasion when the truck is low on fuel and the burner won't operate it, it's just because of that. It can't get enough fuel. Time to add more diesel to the truck. Going on back here, this is a hydraulic tank. Got a sight gauge on it, and you should be able to see fluid in that when it's cool. When it warms up, it'll totally cover that sight glass. It's type F, automatic transmission fluid, Ford type. Pick it up at any gas station, buy it at about any grocery store these days. Hydraulic filter, this is the filter on both hydraulic systems, both the hydrostatic transmission and the auxiliary hydraulic system that raises and lowers the wings. Got a vacuum gauge on it. That vacuum gauge now is down at 0. When it gets up, if it were to get up in the neighborhood of 10, that's 10 inches of mercury. If it gets up in the neighborhood of 10, it's time for a new filter. Typically a filter will go an entire season. If you're running a lot of water, that is, if you travel when it's raining quite a bit with the machine, you tend to pick up moisture in the hydraulic system, and moisture will plug up the filter quicker than anything. Easy deal. If it gets above 10 or up in the neighborhood of 10, time to ask for a new filter. Again, type F, automatic transmission fluid. Down underneath is the main hydraulic pump as well as the auxiliary hydraulic pump. They're in tandem. The auxiliary pump is plugged onto the back of the hydrostatic transmission. That is the variable volume end of the hydrostatic transmission. It's driven by a truck transmission power takeoff, or on some units it may be mounted up front off of the crankshaft, driven by the crankshaft, just like a mixer truck application. That hydrostatic transmission is the unit that drives the asphalt pump, and we're going to talk a lot about that just in a little bit here. Going on back here, this is the toolbox to keep your wrenches and odds and ends of things that you need on an asphalt distributor. Here on the front corner of the tank, Bill, is the float gauge. This shows the amount of liquid in the tank. Right now it's reading 1,450 gallons. It's just marked every 100 gallons, and you just have to interpolate in between. Don't attempt to read it down to 10 gallons. If you get down to that kind of numbers, you're reading numbers that it can't be that accurate on. The float gauge, of course, is affected by the up and down grade as well as the side grade of the truck. Anytime you're comparing numbers from the float gauge, like if you want to see how much material you shoot out of the tank, be certain that the truck is in exactly the same position as it was when you read the gauge the first time, so that you're not, if we tip this truck down a couple of degrees, the float gauge may change as much as 25 or 30 gallons, so always be in the same position. This has a note on it, do not fire burner below 700 gallons. The reason for that is we have to have liquid covering the burner tube in order to fire it. Liquid must cover the tube in order to take heat away from it. If we were to fire the tube without liquid covering it, say it just half covered it, well then the top half of the tube would become red hot shortly. When it becomes red hot, it'll ignite the vapors that are in the tank, and that ruins the whole rest of the day. So be certain anytime you're heating that you're above that fire line. Going on back on the tank just a little is a temperature gauge, and that's the temperature of the product in the tank. That gauge really is only accurate if you're circulating the tank well when you read that. Anytime you're heating, of course, you're going to be circulating, and if you are circulating, then the tank gauge is pretty accurate. You'll notice some discrepancies in it when you move the truck around, and that's just because of cool and hot material moving past it. Bill, now we're going to talk about spread rate. There's two purposes for all this high-powered machinery. First purpose is to put the asphalt down in the right place. The second purpose is to put it down at the right rate. Again, we're going to talk about gallons per square yard. That's the common nomenclature for what we put down with an asphalt distributor. And that is, if we have 3 feet square on the ground, 36 inches by 36 inches, that's a square yard, we're going to evenly distribute a part of a gallon over that. And we talked before a lot about quarts and 3/10 and whatever. We've been into that just a little bit. We're going to talk about how the machine does that now. This machine uses a positive displacement method of regulating the spread rate. We are going to regulate the amount pumped by the pump by the speed of it. This is a positive displacement pump. For each revolution that we turn that pump, it's going to move a measured quantity of liquid. This particular pump happens to pump 0.48 gallon per revolution, almost a half a gallon. That is, each time we turn the pump one full revolution, it moves 0.48 gallon from the bottom to the top if we're moving in the forward direction. So if we turn that pump at 10 revolutions a minute, it's going to move 4.8 gallons a minute. That is 10 revolutions in 1 minute. 10 times 0.48 is 4.8 gallons. If we were to turn it 100 revolutions a minute, it would move 48 gallons a minute. If we turn it 1,000 revolutions a minute, it's going to move 480 gallons a minute, and anything in between. The speed of the pump multiplied by that number 0.48 gives us the gallons per minute that it is pumping. Now there's no need for you to remember those numbers, and you don't even actually have to understand it. This is all part of the explanation. We have control of the pump with the hydraulic motor. Now this is the hydraulic motor, this is the work end of the hydrostatic transmission. It turns the asphalt pump. Here on the shaft is a gear and a gear tooth sensor. Those two things tell us the speed of the pump. Now they're actually seeing just the speed, but the computer, the electronics, convert that speed into gallons per minute. That's all, that math is already done for you. Okay, there are 3 numbers that determine the spread rate that the machine is putting down. The gallons that we're pumping, the gallons per minute, the width of the spray bar, and of course the travel speed of the pump. I'm sorry, the travel speed of the truck. This particular truck is equipped with a computer, and the computer does the math for you in order to regulate the spread rate. But I want you to understand how it's all done, so that when you have a computer problem, possibly you can override it, you can do it manually, or you'll have some idea of where to look for the problem if the computer isn't getting the information. computer sees three things. It sees the desired spread rate, that is, into the computer we are going to tell it what we want. We're going to say we want 0.3 gallon per square yard, and we'll get into that when we get into the cab and look at the computer and the switching. The computer reads the travel speed of the truck from a gear tooth sensor on the rear end housing of the truck. That is, we count the teeth in the ring gear on the main rear end. The computer sees the spray bar width from the control panel. That is, if we have 16 switches turned on for this spray bar, it reads that as being 16 feet wide. Okay, it takes those three numbers and calculates those numbers together and decides the required gallons per minute in order to create that spread rate at that particular speed at that bar width. It calculates those numbers together, determines the gallons per minute required, and adjusts the asphalt pump to that based on information that it sees here on how fast the asphalt pump is turning. It does all of that 32 times a second every second, so that it is continuously informing the asphalt pump as to the speed that it should be turning. Of course, in order to do that, it has to get its information. It has to see its travel speed from the axle housing, and it has to see the pump speed from the pump gear. Additionally, it must see the bar width from the control panel in order to have all the information to calculate the gallons per minute required. If it's missing any of those items, if it doesn't get ground speed, it considers that a zero and decides that it needs 0 gallons per minute in order to create that spread rate at 0 speed. It's done its thing, but if it doesn't get information, it can't help you out. I want to go over that on the slide rule. The computer does exactly the same thing that we're going to do with this cardboard slide rule. In fact, this is a cardboard computer. Let's take a particular situation. Now, let's say that we arrive on the job. When we get there, someone has to tell us two things. They got to tell us, first of all, a desired rate, what they want to put the material down at, because they've ordered material based on that number. And if they've ordered it right, if we shoot that particular spread rate, the material we've brought will cover the job and we won't have any left over. Now, if they've measured it wrong, it's not going to come out right, or if we spread it wrong, it's not going to come out right. Sometimes that's very critical. Well, it's always very critical. It's most critical if you're 300 or 400 miles from home. If you're 300 miles from home and you put the rate down wrong and come up 100 gallons short, that's a long ways to go for 100 gallons in order to finish off the job. Let's take a look at the slide rule. Let's take a look at the slide rule. Just looking down over the scales. On side 1, starting with the top scale, we've got truck speed in feet per minute. That scale goes from 1,000 feet per minute over to 50 feet a minute. It's a descending scale, and remember that. That'll trick you sometimes. If I ask for 350 feet a minute, of course it's to the left of 300. It would be halfway here, and the normal tendency is to jump off to the right. So remember that that scale is backwards. The next scale is spread rate in gallons per square yard. That scale starts out at 0.05 of a gallon per square yard and goes clear up through 4 gallons per square yard. This going across the most common used 0.05, 0.06, going up to 1/10 of a gallon, 0.15, 2/10, 2/25, there's that quart, 3/10, 4/10, 5/10, and on up. The next scale is pump output in gallons per minute, and it starts clear down at 1 gallon per minute and goes up through 500 gallons per minute. Next scale is the pump output. The next scale is the bar length, starting 1 foot up through 20 feet. Below that are 4 windows that indicate the nozzle pressure. That indicates the pressure created by a certain spray nozzle under given conditions. Now, that is in pounds per square inch. Right now I'm showing a number 1 nozzle at 12 pounds per square inch. Turning the slide rule over, side 2, the area that's not filled in here would be for a specific truck. That is, if it were filled in for this truck, each of these squares would be filled in with a travel speed in feet per minute. That is lining up with 1500, and if we had it in the second gear, if we line those 2 columns together, here we would read the travel speed in feet per minute for this particular truck. We fill those in for each truck when the truck is built. That scale can be used in setting up the spread rate, as well as it can give you a check to see that your instrument is right as far as feet per minute if there's some question about that. Window on the left here is just a conversion window. It converts feet per minute to miles per hour, or vice versa. I'll set 400 feet per minute on the arrow here. If someone wanted to know how fast 400 feet per minute is, it looks to me like it's about 4.5 miles an hour. And you have to look at these straight on. I'm looking at it a little side here, so I might be a little off. Going on down the bottom scale is a calculator to calculate how much material you should use, or if you've already spread it, to see what the spread rate that you put down was. Top scale is bar length, and again that's a backward scale starting at 20 feet going down to 1 foot on the right. Spread rate, again, gallons per square yard. Third row is oil required in gallons. That starts clear down at 30 gallons, I believe, and goes up through 10,000 gallons. Last scale on side 2 is the distance to be sprayed in feet. Scale starts down at 200 feet, goes up to 6,000 feet. Here you can see a mile is marked out here. That's, of course, 5,280 feet. Okay, Bill, let's do a specific setup to help explain how this all works back here. When you get to the job, someone has to tell you 2 things. They're going to tell you the desired spread rate, that is gallons per square yard, and they're going to tell you the width that the job is. That is, that's what they ordered the particular material to cover. From that point, as a spreader truck operator, you've got to make a decision. You've got to decide what speed range, what speed you're going to set up at, and what speed you're going to operate at. And from our vast experience, we've decided on this particular job that we should run 400 feet a minute. So let's take those particular numbers. That is, he told you he wants 0.25 gallon per square yard, and you decided that you're going to run 400 feet per minute. So line 0.25 up with 400. Underneath that, on the bar length, he told you 12 feet. Okay, if I line up 12 feet, I see exactly 135 gallons per minute.
That's correct.
That lines up with that. .25 gallons per square yard, 400 feet per minute, 12 feet wide, 135 gallons a minute. If we go across this scale, we read it 100, 110, 20, 130, 135 right there over the 12 mark. That is 10, 11, 12. What that tells us is that if we drive at a speed of 400 feet per minute, regulate the pump speed to the 135 gallons per minute, if we turn on 12 feet of spray bar, that'll create a spread rate of 0.25 gallon per square yard. Now if we make a change, if we were to speed the truck up and move from 400 up to 500, align 0.25 at 500, you'll see that our pump speed has gone up to, still looking over the 12 feet,
170.
0.25, 500 feet per minute, 12 feet wide. That's exactly right, 170 gallons per minute. Okay, if we were to slow the truck down 0.25, let's slow it down to 300 feet per minute, 12 feet wide.
About 110.
Well, I don't read that as 110. This is almost exactly 100. 0.25, 300 feet per minute, 12 feet.
Yeah.
Very close to 100 gallons per minute. Agree with that now?
I'll agree. Yeah.
Okay. So what that's telling us, if we set the pump at a particular speed, at the travel speed, it creates a spread rate that we're after. This pump is driven by a hydrostatic transmission. This is the business end of that. From the cab of the truck, we can regulate the speed of that hydraulic motor that drives the asphalt pump. We can drive the truck at our setup speed. Here we were setting up at 400 feet per minute. So if we drive the truck at 400 feet per minute, as we hold 400 feet per minute, regulate the pump to the 135 gallons per minute, and the setup is made. Okay, this hydrostatic transmission is driven up from the truck transmission power takeoff or the crankshaft of the engine. Once we have made that setup, that is, we have set the displacement of that hydraulic transmission, we have picked a ratio in that transmission that gives us 135 gallons per minute at 400 feet per minute. Everything here is tied to the truck engine. That is, the hydraulic transmission is tied to the truck engine, and the wheels are tied to the truck engine. All through gears that pump through a hydraulic transmission, which is essentially as positive as gears. Okay, once we've made that setup, now that's telling us that if we speed the truck up, the pump will speed up with the truck. Mm-hmm. And if we slow the truck down, the pump will slow down with the truck. And it's all in direct proportion. And it'll do just exactly what we did with the slide rule there. That is, once we've made the setup at some particular number, we picked 400 feet per minute to set up at. Once we've made that setup, as long as we stay in the same truck gear that we set up in, and as long as we stay at that spray bar width, our spread rate will remain exactly the same, even if we speed up or slow down, because the pump is speeding up with the truck and it's slowing down with the truck, and it stays exactly where it should be. That's the positive displacement method of spreading. That is, we are regulating the gear pump here to meter the asphalt onto the ground. In order to do that, we have used a hydraulic transmission to regulate the speed. That gives us an infinite number of gear ratios in the hydraulic transmission so that we can set that pump speed at exactly 135 gallons per minute when the truck is traveling 400 feet per minute. Infinitely variable ratio transmission essentially is what the hydrostatic transmission is. It's just like having a 10,000 speed gearbox. We can select the gear ratio in that gives us the exact speed for the pump at an exact travel speed. Now when we're spreading with the positive displacement system, everything has got to go out the spray bar. That is, we've metered the material with the gear pump. If we've metered it with the gear pump, once it's been metered, it's got to go on the ground in order to create that spread rate. If somehow it could leak back into the tank, then we wouldn't be getting that spread rate. First way that that could happen is if we had left the tank circulate line. If that valve were cracked slightly, well, then some of this material that we have metered in order to regulate the spread rate could leak back into the tank. If it's going back in the tank, it's not going on the ground, and our spread rate on the ground isn't right. Also, at the end of the spray bar and at the end of the spreading system is the air relief valve. If for some reason that relief valve didn't close, well, it would let material leak back into the tank, and again, our spread rate wouldn't be right. If we've metered it with the pump, then it has to go out on the ground in order for our rate to be as we have set it up. And of course, the only way that this would be a problem is if we had some mechanical malfunction, but that is one of the first things to have in mind. If the spread rate is coming up light, you need to determine if that relief valve is functioning as it should. The computer does everything that we've done with the slide rule. That is, it reads the travel speed of the truck off of the ring gear in the rear axle. It reads the spray bar width off of the switches on the control panel, whatever we have turned on. And it reads the desired spread rate from the window that we've filled in the computer. That is, we told the computer we want to spread 0.25 gallon per square yard. It sees those three numbers and calculates the fourth based on the first three. That is, desired spread rate, bar width, travel speed. It takes those three pieces of information and calculates the required gallons per minute, just exactly as we did with the cardboard slide rule. Then it adjusts the asphalt pump to that required gallons per minute based on feedback that it sees down here on the gear tooth sensor. It does all that through the front half of the hydrostatic transmission. If we were regulating this manually, in the cab we have a manual position on the controls, and we would dial in the gallons per minute required at the travel speed. Now when it's in the CRC or computerized rate control function, it does that automatically. That is, it calculates and adjusts the asphalt pump to that. Again, it's got to have all its information. It has to have travel speed from the rear end. It has to have bar width from the control panel. It has to have desired spread rate from what we've put into it, and finally it's got to have gallon per minute information. If it has all that information, then the computer exactly regulates the asphalt pump to the required gallons per minute. It does it nearly 100 times a second, so every second it has readjusted itself 100 times to compensate for any changes. That is, if we change bar widths, if we change travel speed, if we change truck gears, or if we did all those things at the same time, the computer is readjusting the output of the pump over 100 times a second, so it is always immediately the right amount of material going out on the ground. Question?
Every time you go out on a job, do you have to program the computer yourself, or you guys already pre-programmed it? Or?
The only thing you do to the computer when you go to the job is to put in the desired spread rate. That is, the computer knows all these other numbers already, and all you have to do is, and we'll get into that when we get into the cab, all you have to do is hold the switch up or down until a computer reads the spread rate that you desire. In this case we want 0.25, so you would hold that switch until the computer read 0.25. When you let go of it, it continues to read 0.25, and that is exactly the spread rate that it'll put down. And that can be changed at any time. You can change it. You can even make that change while you're spreading. That is, if you're going along putting down 0.25 gallon to the square yard and the road engineer told you that he wants to up the rate to 0.35 gallon per square yard when you get to the shady areas, and that's fairly common when you get back east. They like to see a little bit more asphalt on the shady areas. As you got to that area, you could just hold the computer up to where it read 0.35, shoot through the shade, and when you come to the other end, hold it down until it reads 0.25. You can make any of those changes while you are spraying with the machine. The computer is extremely accurate if it has all of the information, if the sensors are giving it good information. Anytime if you were to have a computer problem, the very first thing we're going to ask you for is a sensor check, and we'll get into how you do the sensor check the first time that you have a problem. That is, the computer itself has a method of checking its sensors to see that its information is good. The computer, as well as regulating the spread rate, also monitors the pumping of the liquid when we shut the spray bar off. That is, it goes into circulate mode. When we turn the spray bar off, the computer sees that we've shut off, we've gone from spread to circulate, and it then tells the asphalt pump to turn at a predetermined speed. That is, we have put into it 30 gallons a minute, or maybe 40 gallons a minute. That's something that you can change in the computer. That is, you can regulate the idle gallons per minute. And all that means is anytime you shut the spray bar off, the computer then tells the pump to idle at 30 or 40 gallons per minute, whatever you set into it. Now, if we didn't have the computer, we still make the setup just as we started out here. With the cardboard computer, we pick a travel speed, we set the desired spread rate on that, read the bar width, and then adjust the asphalt pump to that gallons per minute that we read on the cardboard calculator, adjust it to that when we drive the truck at that particular speed. Now, if we had this back section all filled in, that is the feet per minute in the particular gear at a particular engine RPM, then we don't have to make a dry run. Then we can, let's say that on this particular truck we looked down and saw that at 1200 engine RPM in the second gear, we saw 400 feet per minute. Okay, so that means on this truck, all we have to do is hold the engine up to 1200 engine RPM. While we're doing that, dial the pump in to read the 135 gallons per minute that we had for this particular spread rate. Okay, because we know that this truck will travel 400 feet per minute at 1200 engine RPM in the second gear. So we don't have to go out and make a dry run. We can do that while we're parked. Once we've made that setup, then we put it in gear, take off spreading. Anytime we make a setup like that based on this chart and based on the engine tachometer, neither of which are extremely accurate, we want to double check our setup. That is, just as soon as we start spreading, go to the set speed. That is, we set up at 400 feet a minute. That's the speed we know the number for. Go to that speed and see that the pump is turning 135 gallons a minute when we're at that speed and that bar width, the 12 feet wide. Just double check it there. And if it's slightly off, let's say that we make our initial setup, then we take off spreading, and we see that at 400 feet per minute we only have 125 gallons a minute. While we're spreading there, just dial the pump up and get it on that 135 gallons a minute while you're in actual operation. Double check your initial setup. And always do that for any manual setup, because there's some inaccuracies both in the truck engine tach. It's not extremely accurate, and this chart is just filled in to the nearest 10 gallons per minute, so it's not exactly accurate, but it's plenty accurate to start out your shot with. Okay, again, remember, if we were spreading manually this way, not with the computer, but manually, and we've made that setup. As long as we stay in that gear that we set up in and we stay at that bar width, our spread rate is going to be exactly right. We can speed up or slow down, and because it's driven by the hydrostatic transmission, which is in the end tied to the ground because of the wheels and the driveline and the transmission and whatever, everything is relative. So if we speed up, the pump speeds up. If we slow down, the pump slows down. That is the advantage of a hydrostatic asphalt distributor. That is, the hydrostatic transmission gives us this infinitely variable ratial transmission that enables us to do that. Of course, with the computer, we've gone one step further, and now we control the pump with all the numbers rather than just the ground speed number. Now, if we didn't have the computer on this truck, we would have a adjustment in the cab where we could regulate the pressure on the relief valve. And if this were not a computerized truck and we wanted to change bar widths while we're spreading, we can do that, but we don't do it by positive displacement. We do it by controlling the pressure. Looking back on your slide rule, if we set 0.25 on 400 feet per minute. Let's say we have number 3 spray nozzles in this truck. We've got 0.25 on 400 feet per minute. Question?
Is the number 3 spray nozzle standard on generally every bar, or depends on
the trucks, when they leave our plant, have either number 2s or number 3s in the spray bar based on our best guesstimate of what you're going to do with the truck. Maybe when we go through the first training, we may decide that for the particular type of work that you do, you should have number 2s in it rather than number 3s, or maybe number 4s. The truck comes with one set, and you're welcome to have any size set that you want. And of course, we're glad to sell you the other nozzle sizes. Let's say that this particular truck has number 3s in it. We've set 0.25 on 400 feet per minute. In the number 3 nozzle window, I see 8 psi. Okay, 8 psi is going to be the pressure created by this size nozzle, a number 3 size nozzle. It takes two things to cause or create pressure. It takes a supply of the liquid, and it takes some resistance to the flow. That is, if we took the nozzle out altogether and we pumped 135 gallons a minute through this spray bar with no nozzles in it, we'd see zero pressure. It'd all just be falling out on the ground because there's no resistance to the flow. If we had number 1 nozzles in it, you can see that that's clear off of the scale. We'd have tremendous pressure created if we were pushing 135 gallons per minute out through number 1 nozzles because of the little bitty hole. If we had number 2 nozzles in it, it's going to create a little less pressure. I see 20 pounds per square inch. Of course, number 3 we saw 8 pounds. Number 4 is a pretty big hole, so you can see it goes clear down to 4 pounds per square inch. Now we say that you should work somewhere between 4 psi and 12 psi. That's the ideal pressure range to be working in. The ideal pressure, let's say, is 8 pounds. Everything this works perfectly at that. If you work above 12 pounds, you're going to create a lot of overspray. That is, you're pushing the material out of the nozzle so hard that it atomizes, creates a lot of overspray, and that this gets this fancy machine all dirty. If you work at 8 pounds of pressure, if you keep your pressure down in that range, then it all goes on the ground instead of all over the truck. So we're going to emphasize that you work at low pressures, somewhere between 4 and 12, ideally somewhere around 8. It'll fan just fine right down to 2 pounds, and as long as you're paying attention and watching the spray, you can go down that slow. If you go any slower, then you don't have any pressure and the fan will turn to a dribble, and then you create streaking on the road.
If you had a mild wind, would it hurt to increase the pressure a little bit, or?
Well, if you have a mild wind, then you have to pick the speed that looks like it's working the best. And really all you're going to do to see different speeds is to change the travel speed. I'm sorry, to see different pressures. You can see that at 0.25 on 400 feet per minute, a number 3 nozzle creates 8 pounds of pressure. That is, we're pushing 135 gallons a minute through that size hole, and that resistance creates 8 pounds of pressure. If you speed up, 0.25, move it over to 500 feet per minute. Okay, number 3 nozzle right then went up to 13 pounds of pressure. Because now we're pumping, on 12 feet of bar, we're pumping almost 170 gallons a minute through that same nozzle size. Pushing more material through it, makes higher pressure. And we see that the pressure went up to 13 pounds. 13 pounds is going to start to make some overspray. Now if it takes 13 pounds of pressure in order to get the material from the bar to the ground in this particular wind condition, then you might have to run that hard. Also, just be aware that she's going to get dirty, because we're getting into the range that's creating overspray. If we're in a windy condition, that overspray is going to get all over our nice clean machine. If you stay down and be around 8 pounds all the time, it all goes on the ground. You'll get a little bit on the spray bar, and that's it. You won't get anywhere else. Also on the ground, the 8 pound pressure does an ideal job as far as the way the fan hits the ground. The wind conditions you have to compensate for on the job and see what works the best. Okay, if this particular truck were not computerized and we're regulating the spread rate manually, we said that it stays the same as long as we stay in the same gear, or we stay the same width. Okay, if we change widths, then our spread rate goes to heck. But we can adjust for that. That is, we have a method that we can actually regulate the pressure on this. In the positive displacement method, the first method where the pump is metering the material, everything we meter goes out on the ground. In that case, we want the relief valve set high. It wants to be well above the actual spray bar pressure, so nothing goes back through the relief valve. When it's on computer, the computer has that set clear up at 50 pounds, way above our actual spread pressure. Okay, if we're manually spreading and we need to change the bar width, of course, if we narrow the bar down, it's going to try to increase the pressure, because we've cut down the number of holes that the material can get out, so we've increased the resistance. When we increase the resistance, the pressure goes up. So if we're going along here spreading it, let's say we hold it at 400 feet per minute, our pump is turning 100 and... got my numbers wrong here. Pump is turning
145.
135. As we narrow down, the pump is staying the same. That is, we're still pumping the 135 if we narrow down. We're back on manual here. Okay, at first there we saw 8 pounds of pressure. That is, we could get out the slide rule, or if the truck is not computerized, there would be a pressure gauge on the control panel that shows the actual spray bar pressure. Okay, as we hold 400 feet a minute and we read the actual spray bar pressure gauge, we would read 8 pounds. Okay, now if we back the bypass valve down, the pressure gauge in the cab on the bypass valve, if we back that down to the 8 pounds, then that's the maximum pressure that the relief valve can create. And as we narrow the spray bar down, the relief valve would let, or the bypass valve would let, the excess flow go back into the tank, because we have set it at 8 pounds, and when it tries to make more pressure, the excess fluid goes back into the tank. Now that's on a non-computerized machine. On the computerized machine, of course, the computer is going to regulate the speed of the pump. We could do it that way on the non-computerized also one, but you're just not fast enough to shut off a foot of spray and then reach down and change the speed of the asphalt pump to the right place. You can't keep up with it. So in order to change bar widths with a non-computer truck, we have the relief valve. And we use, we have the bypass valve then, and we use that bypass valve to regulate the pressure when we're changing widths. If we're shooting a constant width, the most accurate method is the positive displacement. That is where we set the pump at exactly the right speed for the ground speed and bar width, and set the pressure high on the bypass valve. Set it up around 30 pounds so that it's well above what our actual spray bar pressure is that's created by the size of the spray nozzle. Now, does any of that make sense?
Yeah, what we're going to do is, on the manual, we've already got this all figured out. Number 3 nozzle is going to spray at 8 pounds of pressure. You're going to set that regulator at 8 pounds of pressure. You're going to lengthen the bar, and it'll catch up.
Exactly right. And lengthening is just one notch more complicated. If we're going to lengthen the bar, we were only pumping 135 gallons a minute, which is enough for 12 feet. If we lengthen the bar, now our pump's not turning fast enough. So as we lengthen out, we also have to speed up the pump. So in the manual situation, if you're going to be changing widths, then set the pump up for the maximum width that you will be spreading. That is, set your pump speed. Let's say on this one we're going to do this parking lot, and this is a manual machine. We would say, okay, the most we can spread is 16 feet wide. So 0.25, 400 feet per minute, 16 feet wide. I see 180 gallons per minute. Do you agree there? Okay, if we're going to do this manually, we would run the truck at 400 feet per minute, dial in 180 gallons per minute, because now we've got enough for the maximum width. Set the bypass valve at 8 pounds. Okay, now notice on the slide rule that the only speed that 8 psi puts down 0.25 gallon per square yard through number 3 nozzles is 400 feet per minute.
Right.
So that means that if we are using the bypass valve, we have to run a constant speed. That is, we have to maintain that travel speed. If we maintain the 400 feet per minute, then we can cut the spray bar down, and the bypass valve will compensate for changes in width because it won't let the pressure go any higher than 8 pounds. And the excess will then go back into the tank. All that we just went through as far as spread rate regulation manually, of course the computer does for us. If the computer's working, or if you have a machine with a computer on it, it takes care of all that. All we have to do is set into it the desired spread rate, and it does everything else. Slide rules, spread rate calculation, all that has run off a lot of perfectly capable operators just because they were intimidated by this or by the numbers. The computer does all that for us. It leaves us to worry about putting the material down in the right place at the right time. We don't have to think about spread rate with a computer. You need to understand what's going on back here so that if the computer quits, you can regulate it manually, or you can determine what the problem is with the computer. You can see that for the computer to know how to make its adjustments, it has to have information. It has to have gallon per minute information, it has to have travel speed information, and it has to have bar width information. If it has all that information, then it can do what it needs to do if everything mechanically is functioning. Any more questions about spread rate or spread rate regulation?
On this pump here, this gear with the little teeth on it, How does, I see it's all notched out, how do you know your notches, if a piece of dirt or something was in there, would it foul it up?
It does make a bit of difference. Those gear teeth could be totally filled up with asphalt and rock and anything else, as long as the spacing from the gear tooth sensor is about right. And on the computer trucks, if that spacing is somewhere around 10 to 15 thousandths of an inch, that's just fine. Good rule of thumb is just if you need to check that, you can just screw it in to where it touches the gear tooth and then back it out a quarter to a half a turn, and that'll set the spacing just right. If those gear teeth were filled up with iron graphite powder, then it would be a problem because that's magnetic. But normal rock, dirt, asphalt, none of that is magnetic, and that's what it's seeing, is the magnetic field going by there. Clean, this makes no difference at all. And the chances of it being filled up with iron powder are slim to none. So what we're getting down to is just the clearance. If that clearance is right, that's right. If the clearance is right and it's still not getting the right information, either it has a connection problem, the sensor is bad, or possibly there's something wrong with the computer itself. We've talked about spread rate, we've talked about how the machine works back here. Just a few precautions that we should go over. Probably the most volatile, most dangerous condition that you can have with an asphalt distributor is when you go from hot material to cold material back to hot material. And the reason being, most cold materials that we spray in the asphalt distributor are some sort of emulsified asphalt material, and that means it has water in it. Okay, if it has water in it, if the product has water, and some people just call it emulsions, some call it by the particular designation. Any emulsion would have some letters in it. It might be CRS2 or SS1, some particular designation like that. If it's emulsified, it has water in it. Water boils at 212 degrees at sea level. At 5,000 feet, it boils at somewhere around 205 degrees. Okay, if the water boils in the tank, it makes steam, and 1 gallon of water creates about 3,000 gallons of steam. So if we boil a gallon of water in the bottom of that tank, it instantly turns into 3,000 gallons of steam, and that has to displace something. Everything has to be someplace, and if you instantly make 3,000 gallons of steam in the bottom of that tank, it's going to crowd some asphalt out of the tank in order to make a space for itself. And it does that very violently. It'll do it so violently that it'll blow the lid off of the tank, and it'll be a geyser that goes up in the air 100 feet. We've seen asphalt geysers 100 feet. We've seen these things start out with 2,000 gallons of material in a 2,200 gallon tank and boil so violently that after it was all over with, there may be only 500 gallons of liquid left in the tank. That means all the rest of it is scattered all the way around this parking lot. If you go from cold material to hot material, you have to take some very definite precautions. A lot of places won't even let you load the truck if it was wet the day before. They talk about wet and not wet. If we had emulsified asphalt in this yesterday and we went to a tank farm and we wanted to load hot asphalt, material that's 300 or 400 degrees, anything over the 212, if we wanted to load hot asphalt, they may not let us. If you understand what you're doing, you can load it just fine. If the tank is wet, of course, if you spread emulsified materials and have any idea at all that the next day you're going to spread a hot material, you want to be very careful to totally empty this tank out. Totally empty the tank and the spray bar. Some days it'll come up as a surprise. Maybe the schedule changes altogether, and yesterday we sprayed SS1. Today they tell you to go load paving grade asphalt. Well, that's a surprise. Maybe we didn't get it totally emptied out. First of all, if we can flush it, that's the best. That is, if at the particular loading facility, if we can load it with some asphalt material that's less than 200 degrees. Say we can load it with MC250 and the material is only 180 degrees, that's ideal. We would load the tank, circulate the spray bar, and offload it. That'll get the moisture out the easiest way. It actually gradually cooks it out of the material. If we can flush it, that's great. We flush it and then we load the hot material. If we can't flush it, then our only choice is to load the hot material. First job is to load the tank. Put some in it. Put a little bit in it. I say no more than 25% of the volume of the tank. This is a 2,000 gallon tank, so put in no more than 500 gallons. That asphalt's on the bottom, the water's on the bottom. Drive it around, shake it around. That'll get the water boiled out of it while there's room for the steam in the tank. The steam can boil up through the low level of the asphalt and get on out of the tank. Once we've got the tank dried out that way, then circulate the spray bar. You'll need to circulate it now when the tank is low, so that as the material circulates through the spray bar and pushes the water that's in the spray bar and the piping into the tank, it has room to boil out after it gets into the tank. Now, if for some reason we ended up on the job with the tank full of hot asphalt and the spray bar wet, and then we've got even worse situation, because if we circulate that wet spray bar into the tank, it's going to push the water that's into the spray bar into the bottom of the tank. Worst place for the water is going to boil out, and we've got a terrible mess. If we get to the job, a tank full of hot asphalt, spray bar wet, then we want to set it up and be sure that the first bit that we spray goes out the spray bar and nothing circulates into the tank. And the way we would do that would be to open the spray bar valve, open all the valves in the spray bar. That is, open up all the sections and back the thing over a ditch. Get the pump running in the forward direction, and last, open the tank valve. That is, now we've got the pump running, the spray bar is in the spread condition so that the bypass valve is closed. Okay, now if we turn the asphalt into the pump, it's going to go into the spray bar and push it right directly onto the ground. Let 30 or 40 gallons go out on the ground. Then we can shut the bar off and let it go into the circulate condition, because we've pushed the water onto the ground and we're not going to have that boiling condition. That's a rare occasion. That'll come up now and then, and it's you've got to know about it. Anything over 212 degrees creates steam if there's water in the tank. Steam displaces a lot of asphalt, and it does. It's very powerful. It'll push that asphalt right on out of the tank. This is the control panel for the 501 Bearcat spreader. Going over the panel, of course, the very first thing that you would ever do when you come to the job with the truck is to put the power takeoff in gear. Just a rule of thumb, when you get to the job, put the power takeoff in gear. When you're all done, ready to go home, take it out of gear. Push the clutch in, put the switch up, and the PTO goes into gear. You can go highway speed, you can go any speed with it with the power takeoff in gear. In fact, some of the trucks that we build won't even have a power takeoff. That is, if they are crankshaft drive, no power takeoff. Going down the panel, up on the top left here is mostly to do with pump. This particular truck, of course, is computerized. Switch says CRC and manual. Any time that it is in the CRC position, the computer, that's for computerized rate control, the computer manages the speed and the direction of the pump. That particular switch has a second position, which is manual. In the manual position, then we can control the direction of the speed. That would be forward, center off, reverse. and we can control the speed. That's just like the volume control on the radio, other than that it goes 10 full turns. It's a very fine control. You can get very fine control. Again, the speed control and the direction switches only work when the CRC switch is in the manual position. If we're in CRC, then the computer totally manages the direction and the speed, and these two switches are phased out of it. They have no effect when it's in CRC. Normally, if you're in CRC, leave these switches in the center off position and the speed turn clear down to 0 here. The reason we leave that at 0 and the center off position is so that if we go to use the manual control from the rear of the truck, the front isn't trying to override it. Most of what we do is going to be in the CRC position. Over here we've got a footage switch. The footage switch has 3 positions. It's got master. That means that anytime the switch is in the up position, whenever you turn the master switch on, the computer is going to measure the footage. Anytime you turn the master switch for the spray bar off, it'll quit measuring, so that this shows distance sprayed. Center off position. Down position, this turns the footage measurement on. If we want to measure a distance or check a speed, just flip that down and nothing else has effect on it. This switch would be for a tank valve. If this truck had front suction, then it would probably have remote operated front and rear suction. Switch in the center position, both tank valves would be closed. In the up position, the front tank valve would be open. That's if we were going down a steep hill, spreading and needed to empty the tank out then. In the down position, it would be pumping out of the rear of the tank, the rear tank valve. A short tank like on this truck, there's no need for the front suction, so this option hasn't been taken. That can be changed on the fly. If you're spreading and going uphill and you come over the top of the hill and you're fairly low in the tank, you should switch it right then over to the front suction so that as you're going down the hill, it doesn't lose suction in the tank. Last one here is just a beacon switch. This particular truck doesn't happen to have a beacon on it, so the hole is plugged. Mirror, up, down, and in and out. Just as it's marked, the up position and in position is the normal go down the highway setting. That is, for normal highway driving, you would adjust the stops on the mirror for the up position and the in position. The down position and out should be adjusted so that the end of the wing of the spray bar is in the center of the mirror for your driving position, so that you can pay close attention to the end of the spray bar when you are spraying. Master switch. We've talked a lot about the master switch when we were back at the back end of the truck with a lot of discussions about when the master's on and when it's off. Well, this is the spray bar master switch. What it does is it turns on whatever spray bar that we have pre-selected as far as width, as well as it'll turn on the footage meter, and it'll turn on the computer when we're in computerized spread rate control. Anytime the master switch is off, all those functions are turned off if they're in the master position, and the computer goes into the idle mode. Spray bar swing, momentary sideways just as it was at the rear. Lift is momentary up and down. And the wings. This particular truck happens to be equipped with a double folding wing, so it has a pair of switches for each wing. Top switch is the outer wing, bottom switch is the inner wing, and of course left and right. Going on down the panel, got a line marker clear on the left end. Of course, that's a single nozzle on the end of the spray bar for marking out lines or for extending the width of the spray bar by one nozzle. It's a 3-position switch. Again, in the master position, anytime you turn the master switch on, That comes on with whatever else spray bar you have selected, and essentially what it does is lengthens the bar out a little bit in that situation. This truck is a 16-foot spray bar with both markers turned on. Then we'd have 16 foot 8 inches of full coverage. Center position is off. In the down position, the line marker comes on by itself. That's when we want to mark out a line. We don't have to fool with any of the other switches. Just turn that on, mark the line, and turn it off when we're done. Left wing going across, this particular truck is in 1 foot sections, 4 feet on the left wing. Then the main bar is 8 switches long, or 8 feet long, and the right wing below, 4 switches for the 4 foot right wing. Everything here up is on, down is off. Right hand marker, same as the left hand marker. Master position, off position, on to marker line position. Center off. Any questions that far, Bill?
Back to the footage here. Master, it goes with CRC, right?
Okay, on the footage, the master position is, that is, if we're making a spread, if we have everything set up here to make a spread, we would put that in the master position. So that now when we turn the master switch on, the truck opens up and the footage meter turns on. When we turn the master switch off, the spray bar shuts off and quits measuring the distance. That's so that it shows us just the spread distance. From that we can calculate to see if our spread rate has come out right.
Okay.
Anything else in question there?
That's it.
Okay, now we're going to get into the computer. This particular truck is computer rate control. The hardest thing there is to explain about the computer is how simple it is to use. When we arrive at the job, the very first thing we'll do when we get there is to stop, set the brake on the truck, put the power takeoff in gear, as we did. Go to the back of the truck, open the appropriate tank valves, get the valves arranged at the back of the truck to be in the spread and circulate condition. If we're ready to go, come back into the cab, turn the computer on. As it turns on, it'll come up and say Bearcat. Then it says idle, FPM, GPM, spray bar. Right now in the idle, it's got an arrow flashing at it there. It's telling us that it's ready to idle or circulate the spray bar at 40 gallons a minute. Okay, and as soon as we turn that computer on, it'll tell the asphalt pump to do just that. That is, it will start turning the asphalt pump and it'll turn it at 40 gallons a minute. Idle speed, circulate speed, that's the same thing. And any time that the master switch is in the off position, the computer will be in the idle mode. It knows that any time we're not spraying with the spray bar, it should circulate the spray bar, and it'll circulate it at whatever that idle number is. Now if we wanted a different idle number, we can change it. If we hold this switch down, 1 click at a time is 1 gallon a minute, or if we hold it down, it'll run on down. There we went down to 9. If we want it higher, again 1 click at a time is 1 gallon per minute. Holding it up, it'll take off and run on up. Wherever we let go, it'll stop. Normal operate GPM should be in the neighborhood of 30 to 40 gallons a minute. I like 30 gallons a minute for most everything that I'm going to do, so I'll set that on 30. Okay, on across the computer, the next switch in the up position shows erase. In the down position it says select. And all that does is to select 3 different modes that are available on the computer. If I click it one time, now we're going to see a window that is a nozzle size window. It's showing us what nozzle size we should have in the spray bar for the spread conditions that is currently seen, and it reads how wide we're spraying and how many gallons per minute we're pumping, and understands what size nozzle we should have in it for that particular situation. Right now it's blinking on the number 1 nozzle size. We're not traveling, we're at 0 ground speed, so it says for this ground speed we should have the smallest possible nozzle in the spray bar. That's not even right information. We should have plugged up nozzles for 0 ground speed. Okay, when we actually spread, as soon as we turn the master switch on and begin spraying, of course we're moving, that will move across the scale to some position. And let's say that it moves over to the 2 position, or partial way between the 2 and the 3. It's telling us for the conditions it's seen, we should have number 2 nozzles in it. Anytime we're near the 2 or above the 2, we should have number 2s in it. If we don't have number 2 nozzles in the spray bar, and then we've got 2 choices. We can either, let's say that we have number 3 nozzles in the spray bar, and it's blinking on the number 2. Well, that's telling us that it thinks we should have a smaller nozzle in it than we actually have. So we should either speed up. We either got to speed up to get that to move over into the 3 position that we have in the bar, or if we need to run as slow as we are running, we should stop and put in number 2 nozzles. Okay, the next scale on the computer, if we click the select again, shows us the distance, and that's the distance traveled in feet. Right now it's showing 1 foot. It goes in 1 foot increments. If we turn the footage switch to the on position and drive, that'll register feet. If we have it in the master position, the footage switch in the master position, anytime we turn the master switch on to spray, it will measure the distance in feet. Okay, when we shut the master switch off or the footage switch off, then it'll stop measuring. Now if we wanted to erase that, this second switch over has an erase position in the up position. If we just push it up, nothing happens. You got to push it up and hold it, and then it'll zero out. Okay, now we've zeroed the distance. If we're starting a new spread, we would want to zero the distance, and that does just that. Okay, select again. Now we're back to where we started at. Idle, FPM, GPM, and bar width. It selects 3 times. That is, this goes around and around here. It scrolls around. We're back to the idle position here. Okay, when we're in this where we're seeing idle, FPM, GPM, this is going to be the normal spread position. But we want it to say something besides idle. It can only say 2 things. If we push the second switch up to the erase position, that'll change to GSY, gallons per square yard. If we do it again, it goes back to idle. Do it again, it goes back to GSY. Gallons per, it just ratchets over twice there. Okay, gallons per square yard. There's the spread rate again. And right now it is telling us that it is ready to spread 0.25 gallons per square yard. I see question on your face.
Yeah, I'm not sure how to say it though. Let's just keep going. It'll sink in here.
Okay. Okay, gallons per square yard. There it is. That's the thing that we have talked a lot about at the back of the truck. One of the main things that we're here for is to put down the asphalt at the right rate. It's saying 0.25 gallon per square yard, and it'll say whatever spread rate we had it set the last time we shut down. Whatever we put in there goes into the memory, and if we turn the unit on and then turn it back or turn it off and then turn it back on again, it'll come back saying 0.25. If we want a different rate, let's say we get to the job today and the man tells us, okay, I want to put down 3/10 of a gallon to the square yard. Well, this arrow switch up and down, let's hold it up till we've got 3/10. There's 3/10. That's all there is to it as far as setting the spread rate with the computer. We've put into it 0.3. That's the desired spread rate. From that point on, the computer is going to take the truck speed, that is FPM. It'll take that from the rear axle of the truck. It will take bar width, and right now it's seeing 16 feet. If we change the bar switches here, you'll see that change. There's 15, 14. Let's say today that we're going to shoot 12 feet wide, so we just have 12 feet turned on. The computer reads the bar width from the control panel, from the switches. It can't see the spray bar, it doesn't know anything that's going on back there, it just sees what switches are on. Just a note of caution there, if we had a wing up, let's say that we had the right wing up, the right wing won't spray when it's up because of the mercury switches that we looked at on the back of the truck. It won't spray at all, but if we had those right wing switches all turned on, the computer thinks that the right wing is going to spray. And so it's going to supply enough asphalt for whatever it sees on the switches. If you have a wing up, be sure that you turn it off. Now we just have 10 feet. Let's say that we put down the inside wing on the right hand side, then we've got 12 feet. Again, just be certain you don't have switches turned on for a wing that's in that position. The computer now is seeing we want 3/10 of a gallon per square yard. It'll see the travel speed, the feet per minute, as soon as we start to move. It is reading the bar width from the control panel. Now it will calculate the required GPM and adjust the asphalt pump to that. And of course it does that 100 times a second every second. So as soon as we turn the master switch on to spray, the computer goes from the idle position to the spread position. That is, now in idle, when we have the master switch off, it'll tell the pump to run at the 30 gallons a minute that we had set into it. As soon as we turn the master switch on, it goes to GSY, gallons per square yard, and adjusts the asphalt pump to whatever the necessary GPM is in order to satisfy the desired spread rate, the feet per minute, and the bar width.
Okay, you just answered the question.
Okay.
Because what I was thinking was, you already had it set it, flip that switch back down to...
I'm sorry, I didn't do what you wanted. You wanted to do that.
On your idle, you already had it set at 30. Then when you flip it back to gallons per square yard, it erases that, takes over on what you got punched into that.
Exactly. And we could put that up anytime we want to. If we just put that over, then it's going to say GSY also. The only time we care about the idle number is when we make the setup. And normally you just leave that set. Very rare occasion that you need to say that. Very rare occasion that you need to change that. 30 gallons a minute works very well for nearly everything that you're going to do. So you just leave the 30 gallons a minute in the idle mode, and the GSY is the thing that you're going to change on a daily basis.
Okay.
Then when we come to the end of the shot, of course, when we turn the master switch off, the computer puts the asphalt back into the idle mode. Now it won't necessarily change the reading up here to the idle mode. It'll still say GSY 30 when we shut the only time that it's going to read idle is if we click that up and take a look at what we've got it set at. Okay. Now if we were running the truck now and we had it in this position and we had the master switch turned off, the GPM would be reading 30 gallons a minute, because that would be actually what the pump is turning at. Anytime we shut the master switch off, it goes to that idle GPM. That is all there is to spread rate with the computer. turn it on, set the idle at whatever you want, and if we've decided 40 is what we want, this comes on at 40 every time. We don't have to fool with that. Put that into the GSY position, set the spread rate. Let's say today we want to shoot 4/10 of a gallon. Hold that up to where we read 4. Select the bar width, and that is, we're going to start out, let's say today we're going to shoot 14 feet wide, and we've decided to do it mostly on the left hand side of the truck. There's 14, we're ready to go. We do nothing else as far as setting the spread rate. Now when we take off, when we turn on the master switch, the spray bar will spray. The computer will adjust the asphalt pump to the exact right GPM to satisfy the instantaneous current conditions that it sees, that is desired spread rate, travel speed, and bar width. If we change any of those things, the computer readjusts the asphalt pump to compensate. And we can change anything. We can change the travel speed, we can change the bar width, we can even change truck gears. We can slip it from one gear to another gear, and they will not affect the spread rate at all, because the computer is adjusting the asphalt pump according to the final results, that is according to the speed, bar width, and GPM necessary to meet those requirements.
So if you're at a standstill, it won't do nothing, it won't spray at all.
Exactly. If you come to a standstill, and I'll demonstrate that to you. If we come to a standstill, it sees all the numbers. It sees we need 4/10 of a gallon to the square yard. I see 0 feet per minute. The computer does, because we've come to a stop. It sees the bar width at 14. It calculates those together, and since there is a 0 in there, anytime you multiply or divide, which all these computations are, it sees a 0 on feet per minute, and the spray stops. On the older trucks, earlier trucks that had a wheel that kicked into the tire that was connected to the footage switch, if you did not have the bitumeter, we called it then, if you did not have it switched to engage when you turn the master switch on, the spray bar would spray for about 2 feet just because it still had oil left over from the idle mode, and it would stop spraying. Of course, people thought things were broke down then. Well, it wasn't broke down, we just didn't have any footage information to it. It instantaneously saw 0 feet per minute and decided that at that speed it needed 0 gallons per minute, and that's just exactly what it did. De-stroke the pump down to 0. In the manual position, if we have the computer in the manual position, or if the truck is not computer controlled, it would always be in the manual position. If the truck is not computer controlled, it would have a panel that looks very similar to this. It would have what we call computerized rate metering, and that is the computer would see the rate. It would see the travel speed, it would see the bar width, and then it would calculate those together, and and it would also see the GPM. It would calculate those three together and tell us what the GSY was, and we would have to then control the pump to where the GSY read what we wanted, and we would do a dry run in order to get set up that way. No CRC manual switch, it's always in manual. Forward, and we would control speed of the pump here. On the computerized truck, if for some reason we need to do something in the manual position, we put this into manual, and with the truck running, we can control the speed of the pump with this knob. Of course, in the forward direction for any spreading, reverse direction for loading. Recall when we were at the back of the truck, we talked about loading the truck. 95% of the time on the computer truck, you're going to have the CRC switch in the CRC position. The computer is managing the pump. When it comes time to load it, come to the cab, put the CRC switch into the manual position, put it into reverse, and put it at full speed. And we call that reverse load on the panel. Okay, now we're loading in reverse. We've got it in manual. The pump is running in reverse, and we run it up to full speed to load it. When we get done loading, simply switch this back to the CRC position. Now the pump goes back into the circulate condition. We're done with the manual control here, so put it into the off and put it down to the 0 speed position.
Okay, you put that to manual, reverse load, increase all the way up, and wouldn't you have to get out of the truck and hit your master back there so you could operate it from back there? Or?
No. When you're loading the truck, you're loading it by yourself, and there's really no need to use the rear controls. As you back up to the tank trailer or to the transport, set your brake, move this to manual, put it in reverse load, and put it at full speed. Then go to the back of the truck, hook up the hose, open the trailer valve, and open the one valve on the back of the truck that we talked about when we were back there, and it's loading because the pump is running in reverse already when we get back there. Hook up your hoses first and open the valves. Don't open the valves first. Okay, then when we're done at the back, that is, our trailer has gone empty, close the trailer valve, drain the hose, close our loading valve on the back of this truck, finish whatever you have to do, put the hose away and wash your fittings up. Come back to the cab of the truck. As you're ready to go, just simply move the CRC switch back to the CRC position, off on the direction and 0 speed. As you move that into the CRC position, the pump goes back into the idle forward mode and it's circulating. Again, on the manual operation, I'm going to start the truck, and that's probably going to raise havoc with the camera. We'll find that out here right now. Anytime you start the truck, turn the computer off. It doesn't like the voltage change that it sees as you crank the truck. We're going to operate in manual. I have the computer turned on just to read the GPM. To circulate the spray bar, forward position, and we can dial in the GPM. You can see the GPM reading there. There I'm turning it down to 0. There we see 0. Now if I go to the forward direction, and it's several turns before it starts to move. Now you can see I'm reading 12 gallons a minute. Whatever I dial in here is where it'll stay. And that has very fine control. It'll get to one number and it'll blink back and forth as very slightly. That's mostly the difference in idle speed of the truck engine. For a manual spread setup, from our slide rule we would get the appropriate numbers. We would know the speed and the engine RPM, run the engine up to the engine RPM that we saw on our slide rule, and dial the GPM into that number. And that's all there is to the manual setup. Back in the computer mode, We turn this off, turn the speed clear down, put it into CRC. Now it'll go to idling at whatever is in the idle window. There you see it idling at 40 gallons per minute, whatever we have set there. If we want to change that idle mode, we can do it while it's circulating there. If we want 30 gallons a minute, oh, I went on by, this thing goes fast. There's 30 gallons a minute. Now you'll see the GPM come up to the 30 gallons a minute that we have set in the window. And on up to 40. 30 is a little bit slow. It wasn't quite getting the number. There we go. Now if we go into the spread position from here, I'm going to move this up to where it reads GSY. That's what we want to see. Okay, and I turn it on to spread. Of course, we've got no, we can't move because the camera can't keep up here. When we turn it to spread now, you'll see the GPM will actually go to 0 because it sees 0 ground speed. And there it sees 0, and that's just what it does, down to 0. Turn the master switch off. We go back to the idle number, which we had 40 gallons per minute set in the idle position. Again, when you turn the truck on and off, computer first, then the truck. Mirror position, up, that's the normal down the highway position. Down for the spray bar. In or out for the spray bar. In, up. This is the Bearcat CRC computerized rate control system. Very simple to operate. When we get to the job, engage the valves at the rear of the tank that are necessary for spray bar circulation. Come back into the cab. A CRC switch on the panel should be in the CRC position. That's up. The manual switches here, always leave them off and the speed turned clear down. They only affect it when we are in the manual position, but that's a better place to leave it. Turn the computer on. When it comes on, you'll see Bearcat, you'll see some calibrate numbers come up. Now it says GSY, FPM, GPM, and spray bar. Now the pump has started to turn. The computer, because the master switch is turned off, the computer is in the idle mode, and it'll circulate the asphalt pump at whatever gallons per minute we have in the memory for the idle mode. We can look at that idle speed just by pushing the center switch up to the erase position. Now we read idle 40, and that's what we have the idle speed set at. Anytime the master switch is off, it'll idle at that speed. We can change that speed with the arrow switch. If we hold it up, this number comes up and you'll see the GPM actually come up over here. If we hold it down, now we can go back down. Now we've gone down to 23 here, and we'll see this come down to 23. Normal speed is about 40 gallons a minute. Good idle GPM speed. Seldom have to change that for any reason. Going through the scales on the computer, pushing the select switch. If we go down again, now we'll see the nozzle size. Nozzle size is a function of how much we're pumping compared to how fast we're moving, and the computer will tell you what size nozzle you should have in it. Third thing is the distance traveled. This is showing 140 feet. If we push the center switch up to erase and hold it, it'll zero that number. Anytime we start a shot, we want to zero the number. Select again. Now we're back to FPM, GPM, and bar width. Holding it up to the erase position will put you back on GSY, gallons per square yard. Once we have set the idle position, we only have to do it again if we want to change the idle number. Idle is set at 40, the pump is idling at 40 gallons a minute. The computer sees 16 feet of spray bar. It sees whatever switches are turned on. If we turn on or off the switches, it changes the bar width. To set the GSY, simply hold the switch down or hold it up to the number that you desire. Today, let's say that we're going to shoot 3/10 of a gallon to the yard. A single click is a single hundredth of a gallon. That takes us to 0.3. We've got 3/10 of a gallon set. We have the spray bar set. Now as we start the truck out and turn on the spray, immediately you see we have driven to 259 feet a minute. The pump has come up to whatever number is exactly necessary to satisfy that. It's calculated out that it needs 138 gallons a minute in order to create 3/10 of a gallon to the yard, 16 feet wide at 259 feet a minute. If we speed the truck up, you can see as we speed up, the truck speed comes up, the gallon per minute comes up to match that. Anytime we vary the truck speed, the GPM varies to match whatever truck speed we are operating at. Instantaneous, it makes instantaneous corrections. I'm going to set the truck speed as close as I can to 300 feet per minute. It just so happens that at 300 feet per minute, 3/10 of a gallon to the square yard, we should be pumping 10 gallons per minute per foot of spray bar. There we have 300 feet a minute. We have 16 feet of spray bar, and you can see that we're clicking back and forth from 159 to 160 gallons a minute. That's 10 gallons per minute per foot of bar, or 10 times 16. It's a quick, simple test to see if the computer is driving the pump at the right speed. That is, set 3/10 of a gallon into the computer, hold the truck at 300 feet a minute, and see that you have 10 times the bar width in the GPM. As we narrow down, there's 15 feet. You can see the computer has stroked the pump down to 150 gallons a minute. 14 feet will go down to 140 gallons a minute. 13 feet, 130. 12 feet, 120, and on down. Now, the computer reacts as fast as we move the switches. Now I'm down to 7 feet, and we're at 70 gallons per minute. Right on down. Now we're down to 4 feet of spray bar. We'll go down to 40 GPM. When we get below 25 gallons a minute, sometimes we have a little inaccuracy. Let's see how we do today. There's 3 feet, 30 gallons a minute. 2 feet, down to 20 gallons a minute. At this low of pump speed, we'll see some oscillation because of the size of the gear teeth in the pump. It has a hard time when it gets down this slow. We'll take it on down to 10 feet and see how we do. See if we can hold 10 gallons a minute. Again, because of the size of the gear teeth, it's having a hard time down that low. Very seldom are you going to work at that narrow of width. Going back up, you can see that the computer follows the switches right on up to full bar width. 16 feet wide, we're back at 160 gallons a minute. When we shut the master switch off, when we stop the truck and shut the master switch off, you can see that our GPM goes back down to 40. That's the idle GPM. back again. We've gone back to 300 feet a minute, back to 160 gallons a minute. If we stop the truck, if we were to roll to a complete stop, you see as we're slowing down, the pump slows down. As we come to a stop, FPM goes to 0. Immediately GPM goes to 0. The computer did just exactly what it should. If we want to see how far we went, hit the select. Now we've gone 1,107 feet on this particular shot. Starting over, we want to 0. We're ready for the next shot now. As we're spreading, traveling again now, we're back at 300 feet a minute. I'm slowed down a little bit. I'm going to speed us up a little here. You can see 2 little tick marks over on the side of the bar. Those 2 tick marks indicate that at the speed we are operating, we should be using number 2 spray nozzles. If we speed the truck up, as I speed up, now you see 3. That's telling us that at this speed, we should have 3 number 3 nozzles. That's the same as we see over in this mode. That is on the nozzle size graph. That tells us exactly where we should be. If we want to be at the ideal speed for number 3 nozzles, we should slow down this very slightly. Now we've slowed the truck down very slightly. That's the ideal speed for number 3 nozzles. We can take a look back over here and see how fast we're going. We're at 299 feet a minute. That's the ideal speed for number 3 nozzles. If we had number 4 nozzles in it, just a matter of speeding up. That's the ideal speed for number 4 nozzle. Taking a look here, and now we're at 440 feet a minute and 0.3 of a gallon to the square yard. Again, you see 4 tick marks over here.